Hello Ninja Warriors, welcome to yet another power packed session of the Roar series, and in today's session we are going to finish from starting, from the scratch, from the beginning to the very end of the complex numbers chapter, right? So complex numbers chapters has these many topics. We are going to cover these many topics in the one short chapter. Make sure that you attend each and every topic, because you know that each and every topic which we teach in Roar series is very, very important, right? So we will start with introduction to iota. Like, how does this iota came into picture? What is iota? What is square root of -1? Right? First of all, we will tackle this. Then we will talk about powers of iota. This is, you know, that JEE Main's favorite. JEE Main always gives some basic question which has some powers of iota. And then we will quickly talk about representation of complex numbers. But before that, we need to talk about modulus and argument in detail. So modulus and argument of a complex number, why is it important? And the complex number has argand plane as well. So argand plane, complex plane, we will study all the terms related to complex number, and these two terms are very, very important, modulus and argument of a complex number. Along with that, there is one more term, that is conjugate. So we will understand the properties of conjugate, properties of modulus, and properties of argument. Okay, these three terms are considered as basic or foundation blocks of a complex number. Once we are done with that, then we will talk about representation of complex numbers. How many forms we can represent? Because one form you already know, x plus iota y, a plus iota b. So this is basic algebraic form. Second, it will be polar form. We will talk about polar form in detail. Third, it will be Euler's form. All the three forms are absolutely important. In fact, the second and third form are often ignored form, but these two forms will help you to solve the difficult questions of complex numbers. Do not at all ignore this. Then we will talk about these two topics, which are not only important for JEE Main and Advanced, but also important for your EM set examination and VIT-EEE as well. So de Moivre's theorems and cube roots of unity we will understand. Once we are done with that, then we will talk about the geometry behind the complex number. So especially the geometry of modulus. Okay, and then we will talk about the triangle inequalities. So this is a very small and very crisp chapter. We will study this chapter in crisp manner as well. Make sure you attend from the very beginning to the very end of the complex numbers. Okay, so let's start. So let's talk about the imaginary numbers. So we have talked about that what are real numbers, right? We have seen real numbers, we have played with real numbers, we have spent enough time with real numbers. Now in this chapter, we are here to spend more time with imaginary numbers, right? So imaginary number becomes imaginary when this square root and a negative quantity becomes together. If square root and negative quantity becomes together, then the number becomes imaginary. Okay, so the very basic imaginary number is this, which is square root of -1. We call it as a iota. Iota is what? Square root of -1. So whenever you see square root of negative quantity, you will sure say that this is nothing but an imaginary number. Okay, imaginary number. Clear? Okay, all right. Now let us have a look at this. X squared plus 16 equals to 0. If in real world somebody tells me that solve it, then we will tell that no real roots. Okay, all right. Discriminant of this particular quadratic equation is negative, but since we are in complex numbers, we need to solve it. Okay, so x squared plus 16 equals to 0. This will give me x squared is equals to -16, and x will be equals to square root of -16. Correct? So x will be equals to, or rather, 1 second. Okay, all right. So this is gonna be x is equals to, now the moment you remove square On the other side, you will get plus minus square root of minus 16, right? Now, x will be equals to plus minus square root of minus 16. So, this is minus 1 into 16. So, what we can do is x will be plus minus square root of minus 1 into square root of 16. Now, square root of 16 is 4. So, x will be equals to plus minus iota multiply 4. So, x will be plus minus 4 iota. This is the basic thing to solve any equation, any quadratic equation which has imaginary roots. Plus minus 4 iota will satisfy this particular quadratic equation. Okay, this is just a beginning. The introduction of iota is what we have done right now, where iota is what? Iota is what? Square root of minus 1. So in this whole chapter, I will talk only about iota. So whenever I use the word iota, just understand this is square root of minus 1. Because every time we are not going to write root minus 1, root minus 1, root minus 1. No. You have to have the understanding iota. So it should create a picture in your mind that, okay, iota is square root of minus 1. Okay. Now, integral powers of iota. This is the favorite thing of NT, or you can call it JEE Main. Okay. So you know that iota is what? Root minus 1. What about iota square? If you square on both the sides, iota square will become minus 1. Iota cube. Okay. So that means you are actually multiplying iota in this particular equation, the second one. Multiply iota both the sides. So iota cube is equals to minus iota, my dear students. And iota power 4 will be equals to what? So iota power 4 ke liye, what you have to do is again the second equation ko square both the sides. So if you square both the sides, tell me what will you get? Iota power 4 is equals to minus 1 square. So iota power 4 is equals to 1. So this is your iota raised to power 4. Okay. Clearly, now iota power 5 ke liye what will you do? For iota power 5, you just multiply iota both the sides. So again, iota power 5, this is what? Iota. So iota power 5 is iota. So that's how. And then again, iota power 6 will be again, you multiply iota both the sides. So this is iota square. Iota square is minus 1. Iota power 7, again you multiply iota both the sides. So minus iota. And iota power 8 is equals to what? So again, iota power 4 is 1. Square both the sides. This is also 1. What does that mean? We can generalize it, by the way. If you see, there is a cyclic order going on. Okay. First is iota. Then it is minus 1. Then it is minus iota. Then it is 1. Then again, after this, can you see things are getting repeated? Again iota, minus 1, minus iota 1. Iota, minus 1, iota 1. Iota minus 1, iota minus iota 1. Like that. Okay, you got the cyclic order, right? So, but how are things getting created? So, understand. Iota power 4, iota power 8. Iota power 12 also. So, basically, iota power 4n is becoming 1. Yes or no? Iota power 4n is becoming 1. Be it iota power 0, iota power 4, iota power 8, everything is becoming 1, right? Now, so this is sorted now. So iota power 4n is 1. So if I just multiply iota both the sides in left hand and right hand, what will I get? I will get iota power 4n plus 1 is your iota. This is the second thing. Iota power 4n plus 1 format is the power can be 1, 5, 9, right? So 1, iota power 1 is again iota, then 5, iota power 9 is also iota. Okay. Now, if you multiply one more iota both the sides, so iota power 4n plus 2 will be iota square, which is minus 1. One more time you do that, we are generalizing the result, 4n plus 3. This is going to become minus iota. That's it. Now, next time if you multiply one more iota, then the cycle will get completed. How? So, you multiply iota, so this is again gonna become power multiple of 4. 4n plus 4 is what? 4k. So again it is going to become 1. So this is how it is. So these four things you have to remember, where n is what? N is a whole number, you can say. Okay, n is a whole number. All right. Okay, so yes, this is what we have learned. Iota power 4n is 1, iota power 4n plus 1 is iota power 4n plus 2 is minus 1, and iota power 4n plus 3 is minus iota. And if you do not able to remember it, it is very easy to derive it right away. But we will start solving the problems, then you will realize that, ma'am, we are actually like, we don't have to make any efforts to remember it, because while solving, everything is getting itched in our brain. Okay. All right. So yes. Now one more thing, if you add all the terms, right, 1 iota, minus 1 minus iota, if you add all of these things, you will get a 0. So this will be helpful in problem solving, especially where NTA gives you such problems where summation of iota powers is given to you. Okay, so let's sum of any 4 consecutive powers of iota is 0. So this is a very important note. So you take iota cube, iota power 4, iota power 5, iota power 6. Sum of any 4 consecutive powers will become 0. Doesn't matter it starts from where. It starts from iota power 101. In 101, iota power 102, 103, 104. 4 consecutive should be there. Okay. Chalo, let's do one problem like this. Let's just solve one problem like this. Okay. So as per the question, they are saying iota n is equals to 1 to 13. Right. Let's just first insert the sigma inside. You know how to deal with sigma. The very first thing. Iota power n sigma n equals to 1 to 13 plus iota power n plus 1 and again sigma n equals to 1 to 13. So now this 2 terms are getting created. What about this? So iota power 1 plus iota square plus iota cube and all the way up to iota power 12 and iota power 13. This is the first thing. Plus the second thing will be iota power n plus 1. So it starts with iota square and it ends with iota power 14. Right? Now you know that iota power 12, this thing will become 0. Why? Because 12 by 4. So we are going to get 3, 3, 3, 3. So here also 0. Basically iota power 1 to iota power 4. 4 consecutive terms. Iota power 5 to iota power 8. Again 4 terms. 9 to 12. Last thing which will be pending is iota power 13. Right? So this is 0. This is 0. This is 0. So iota power 13 will be left out from here. And again from here. Also because see there are 13 terms in this also, in this also 13 terms. So 12 will have 4, 4, 4. Right? The last term will be pending. So iota power 14 will be pending over here. Now you know that iota power 13 can be written down as iota power 12 into iota plus this iota power 14 can be written down as again iota power 12 iota square. Correct? Iota power 12 is 1 because 12 is multiple of 4. Again, this is also 1. So this is iota plus iota square. So iota minus 1 is absolutely correct. Right? So final answer of this question is iota minus 1. Basic question on power of iota. Clear? Okay, have a look and let me know. All right, let us move on to the next problem. Iota power 535 plus 1 upon iota power 87. Okay, 535 again. We need to do the same thing. We need to know whether this is multiple of 4 or not. Obviously, it is not multiple of 4, but we need to know the format also. Okay, so we need to divide 535 by 4. 4 ones are 4. 4 then 3 carry. Sorry, 3. 4 3s are 12. 1 carry. 4 3s are 12 again. So 3. So basically this can be written 535 is what? Iota raised to power 4 into 133 plus 3 plus 1 upon iota power 87. To get iota power 87, clearly if I multiply iota, so this is 87, correct? What I am trying to do is multiplying iota in numerator and denominator. You can do anything, like whatever strikes in your brain. But I feel that if I multiply iota in numerator and denominator, this will become iota power 88. So this denominator will go, it will become 1, right? And this, what about this? This is actually iota power 4, 133 iota cube plus iota by 1, correct? This is 1, this is iota cube, which is minus iota, this is plus iota. So finally this question has a clear-cut answer, which is 0. Just let me know that whether you have understood this or not. Okay, so this was the basic question based on powers of iota. So now whenever higher powers of iota is thrown in any question paper or any mock test, or be it your JEE Main actual paper, you won't be like, oh, these are the higher power. You won't be scared, because you know that these questions are much easier questions. You won't be hesitant to attempt those questions, right? Okay, now let us start with complex numbers. Okay, complex numbers, definition of complex numbers, because some people have a misconception that complex numbers are only imaginary. If I ask you that, just tell me about the complex numbers, whether 2 is a complex number or not, majority of you will say 2 is not at all a complex number. I will ask you why. You will say because there is no iota or there is no imaginary part involved. But that is a wrong thing. Complex number is superset of all the numbers. Complex numbers is an umbrella, like superset. It is having natural number, it is having imaginary number, it is having real number, rational, everything. Okay, so complex number is superset. So 2 is a complex number, definitely. Okay, so definition of complex number says a number of the form a plus iota b is called a complex number where a and b belongs to R. The format is like that, but nobody has said that b cannot be 0. If b is 0, then the number will be a. Now a can be 0, a can be 2, a can be 3, right? So 3 plus 0 iota, that means 3 is definitely a complex number. 3 by 2 is a complex number, right? Okay, and iota here is square root of minus 1. Now any complex number will be denoted by z. Complex number will be denoted by z. Now z is equals to a plus iota b, where a is considered as real part of z and b is imaginary part of z. Now understand, imaginary part is not iota. Imaginary part is that thing which is written with iota. So whenever I ask you what is the imaginary part, you won't say iota b. No, it's wrong. It's not iota b, it's just b. B is the imaginary part. Okay, this is also one of the major misconceptions. Okay, so a is real part, b is imaginary part. So complex number definition in a mathematical form, very easy. A plus iota b, a and b both are real, and iota here is actually square root of minus 1. Clear? Okay. Now very important, because in some questions they will give you that this complex number is purely imaginary, this complex number is purely real. So you need to understand this term. If a number is purely real, that means the imaginary part is missing. That means imaginary part b is 0. If a number is purely imaginary, what does that mean? Purely imaginary, that means real part is missing. That means a is 0. All right. Okay. Now, what about 0 plus 0 iota? Is it purely real? Hold on. Purely real. Okay, ma'am. Purely real ke liye there is a condition that b is 0. Is b 0? Yes, ma'am. So 0 is a purely real. Right? And is it purely imaginary? Okay, hold on. What's the condition? For purely imaginary, your a should be 0. So here a is also 0. So this is purely imaginary as well. So 0 is the only complex number which we call it as purely real and purely imaginary. This you can get in your CBSE exam or your school examination, that which number is purely real and purely imaginary. So 0 plus 0 iota, or you can simply call it as a 0 as well. Okay, all right. The set of real numbers R is a proper subset of C. So that's what I'm saying. Complex number is superset. Now, real number is subset of complex number. Real number, all the real numbers comes under complex number. Okay. So complete number system, I was telling you, complex number is the biggest set of all. And now real number is subset of complex number. Rational is subset of real, that we know. Integers are subset of rational. Whole number is a subset of integers, and natural number is subset of whole number. This is the whole complete subset format of all the numbers, be it integers, be it complex numbers, be it natural number, whole number, rational number, etc. Okay, this is the complete you will say complete representation of whole, all the integers, complex numbers, right? Okay, so the biggest thing is complex number. C is the superset of all. Now, one by one, just tell me that whether this is a purely real or purely imaginary. Okay, -2 iota. So we know that B is -2 but A is 0. The real part is 0. If real part is 0, this is purely imaginary. Right? What about this 5? Purely real. Right? Next, square root of -9. So this is actually 3 iota. 3 iota again is purely imaginary. Okay. Next we have root x. Okay, hold on. Where root x is negative. So clearly, any negative number, if you put square root of minus thing, so it will be represented like this only. So it is same. Purely imaginary number. This is purely imaginary number. Okay. Alright. So I guess you have got the picture of what is purely imaginary and what is purely real. Okay. Now equality of complex number. See, when two complex numbers are equal, their real part are equal and their imaginary part are equal. As simple as that. But when two complex numbers are not equal, that means I'm talking about inequality. There is no meaning of inequality. When somebody asks you Z1 and Z2, compare these two complex numbers, the complex numbers are incomparable. Inequality is meaningless in complex numbers, but equality is again same. The complex part is same and the real part is also same. Okay, all right. So yes, the two complex numbers are there. So both are equal if, sorry, this is C plus iota D. Both will be equal when their complex part, when their real part and imaginary part are equal. Z1 is equals to Z2, right? Real part are equal and imaginary part are equal. Okay, let's do one question to understand this better. So suppose this is also a complex number, this is also a complex number. Now we want them to be equal. So real part and imaginary part, real part is 4x, that should be equals to 3. Imaginary part is 3x minus y, that is minus 6. Okay, so x is equals to 3 by 4, and if you put 3 by 4 minus y is equals to 6. 9 by 4 minus 6 equals to y. 9 minus 24 upon 4 equals to y. So y is coming out as minus 15 by 4, right? So x and y right here in front of you. Okay, we've just compared, nothing else. It is minus 6, right? Plus 6 plus. So this is 33 by 4. 33 by 4. Okay, clear? So whenever two complex numbers are equal, we just need to equate. That's it. Okay. All right. Cool. Perfect. And also I already told you that inequalities are not defined. They are meaningless. We will never talk about Z1 greater than Z2. Okay. Z1 greater than Z2, if you see, it's wrong. It's completely not valid. Okay. Now, if you want to add two complex numbers, simply add real part and imaginary part. If you want to subtract two complex numbers, simply subtract real part and subtract imaginary part. Okay. So addition and subtraction will go like this. So Z1 and Z2. So if you want to add clearly, this is Z1, this is Z2, add real part A plus C, add imaginary part iota B plus D. Similarly, subtraction will be like this, A minus C and B minus D, right? Okay, perfect. Now multiplication. Multiplication of two complex number, if you want to do, it's very obvious that you just need to multiply Z1 and Z1 multiply Z2 will be equals to A plus iota B and C plus iota D. Okay, so this is AC plus iota AD plus iota BC plus iota square BD. Okay, that's why I was not telling you simply multiply. Addition mein I told you simply add. Subtraction mein I told you simply subtract. But in multiplication, you have to multiply and then understand AC, then iota. This is the imaginary part. Okay, AD plus BC. And what about this? Minus BD. So real part, iota square becomes minus 1. So this will become AC minus BT will be real part plus iota. Now this AD plus BC will be the imaginary part. That's how you multiply two complex numbers. Okay. All right. Clear. Now, simplify these two numbers and express in A plus iota B form. So obviously, in complex number, what will you do? You will have to rationalize. Whenever you see iota in the denominator, you have to rationalize. Whenever you see square root in the denominator, what do? Now it has like etched in your brain, in your muscle memory, the very first thing. Whenever you see root 2 minus 1 in the denominator, you just multiply root 2 plus 1, root 2 plus 1. You do that, right? You are doing since class 10th only. So these things are already known to you. Now what I'm trying to say is that whenever you see iota in the denominator, now rationalize same thing. So 1 plus iota and 1 minus iota. Okay. How will you do that? By multiplying the conjugate, multiplying and dividing the conjugate of this denominator. What is conjugate? That we will understand conjugate term, but right now just understand that conjugate is nothing but you just have to multiply and divide 1 plus iota. That means you are just changing the sign of the imaginary part and multiplying and dividing. Okay. So this is going to become what? 1 plus iota, 1 minus iota, 1 plus iota square. So this is A plus B, A minus B, 1 minus iota square, and this is 1 plus iota square plus 2 iota. 1 minus iota square, 1 minus iota square is minus 1, and this is 1, iota square is again minus 1 plus 2 iota. So this is 2 iota upon 2 iota. Iota is absolutely right. Okay. So now first thing in A plus iota B form, if I express, so it will become 0 plus 1 iota. Second thing, 1 minus iota upon 1 plus iota. Okay, first thing we already did. Now second thing, second expression, 1 minus iota upon 1 plus iota. Multiply 1 minus iota upon 1 minus iota. What I am doing is, I am multiplying and dividing by conjugate of this. How to create conjugate? Just by reversing the sign of imaginary part. Now just do same thing. Again, 1 plus iota 1 minus iota, and this is 1 minus iota square. So by doing that, your denominator becomes a real number. That's why we are doing that. Okay. 1 plus iota square minus 2 iota upon a plus b, a minus b. 1 minus iota square. So 1 minus minus 1. This is 1 iota square is minus 1 minus 2 iota. 1 1 cancel. Minus 2 iota upon 2 minus iota is absolutely right. So if we convert in this form, 0 minus 1 iota. 0 minus 1 iota is of the form a plus iota b. Okay. So now I am assuming that you know how to rationalize and how to create the another form of a complex number. So whenever you see denominator in any question, try and rationalize it. Your denominator should be a real number. Okay. All right. Yes. Cool. Let us now talk about a question which was asked in JEE Main 2019, which is, let A set is having theta in it. So set A is having theta angle, okay, such that this thing is purely imaginary. Purely imaginary, that means real part of this complex number should be 0. Okay, then the sum of elements in A is equal to. Understand, in this question also we are going to repeat the same thing. What is that thing? So first of all, this should be in the format of a plus iota b. Once we get this complex number in the format of a plus iota b, then for a purely imaginary number, we have just learned that for a purely imaginary number, your real part should be 0, right? So a should be 0. So before writing what is a, we should get this in the form of a plus iota. Before that, what we need to do is we need to rationalize it, because we are seeing iota in the denominator that we do not at all want. 1 minus 2 iota sine theta. How to rationalize it? By multiplying and dividing the conjugate of this denominator. So 1 plus 2 iota sine theta and 1 plus 2 iota sine theta. 1 minus 2 iota sine theta. 1 plus 2 iota sine theta. Okay. Now this multiply this. 3 plus 3 plus 2 iota sine theta plus 2 iota sine theta plus 3 2s are 6 iota square sine square theta. Okay. A minus b, a plus b. A square minus b square. What about this? 3 and this will be minus 6 sine square theta. So this is 3 minus 6 sine square theta. This is your real part plus. This is 4 iota. So iota 4 sine theta. This is now in the form of a plus iota b, right? Where your a. So if you just compare it with a plus iota b, so your a will become what? Ma'am, a will be 3 minus 6 sine square theta upon 1 minus, so this is iota square. So 1 plus 4 sine square theta. Correct? Now this should be 0. What does that mean? That sine square theta is 1 by 2. Or you can say that sine theta is plus minus 1 by root 2. Sine theta is plus minus 1 by root 2. Okay. All right. Now, angle is lying in which quadrant? Minus pi by 2 to pi. Minus pi by 2 to pi. This is 0, this is minus pi by 2, and this is pi. So angle is lying. Okay, so let's do one thing. Let's plot the graph. And options are also given to you. Oops. Options are also given. Okay. Okay. Let's plot the graph. Sin theta is plus minus 1 by root 2. 0 to pi of sin x, and this is your minus pi by 2. 1 by root 2. 1 by root 2 and minus 1 by root 2. Sin theta is plus minus 1 by root 2. Correct? So, in this interval, I can clearly, this is minus 1 by root 2 line. This is plus 1 by root 2 line. How many solutions? 3 solutions. First one is pi by 4. Sin pi by 4 is 1 by root 2, 45 degree. Second one is pi minus pi by 4. Clearly, pi minus pi by 4. Okay. So 3 pi by 4. We know that sin 3 pi by 4 is also what? 1 by root 2. Right? Second quadrant, sin is positive. Now this. This is minus pi by 4 clearly. Minus pi by 4. Okay. First angle, second angle, and third angle. Okay. So A will have 3 theta. Sum of the elements on in A. So if you add minus pi by 4, so if you add, these two are getting cancelled out. Pi minus pi by 4 is the answer. So 3 pi by 4 is absolutely correct. 3 pi by 4 is absolutely correct. Option A is absolutely correct. Okay. JEE Main 2019. Easy question. What do you think? I feel this is an easy question. Okay. Now let us understand, let us dive deeper into complex number. Let us understand the geometrically what a complex number looks like. Okay, so geometrically, so you know that x-axis, y-axis is there in the real world. But when you talk about complex number, you don't have coordinate plane, you have argand plane. In argand plane, there is no x, no y concept. There is a real axis and there is an imaginary axis. Real axis is just like your x-axis, horizontal one. Imaginary axis is your just like your y-axis, that is the vertical one. Okay. Now A plus iota B represents a point in that argand plane. Real axis, imaginary axis. Okay. The concept is same. Just the words are different because we cannot say this is x-axis and y-axis because x and y exist in a real thing. These are the real things. Okay. X and y are relatively real, exist in reality basically. Okay, so complex number z is equals to a plus iota b can be represented by a unique point a comma b in Cartesian plane referred to pair of rectangular axes. Okay, so again axis is there, but this time no x, no y, but a real and imaginary axis. Now origin, what you call it origin is 0 plus 0 iota in this argand plane. Okay. All right. Yes. So again, purely real number, that means the imaginary part is 0, right? This is purely real number, imaginary part is 0. So that means a plus 0. So a comma 0 basically, this is a comma 0. So it lies on x-axis. But x-axis we do not call, we call it as real axis. Okay. So if a number is lying on the real axis, that means that number is what? Purely real number. Similarly, if a number is lying on imaginary axis, that means the real part is 0. So that means we call it as purely imaginary number. Okay. All right. So this we have already covered. A number lying on real axis is purely real. Number lying on purely imaginary is purely, number lying on imaginary axis is purely imaginary number. Okay, and also we can call argand plane as complex plane as well. Both are same thing. Plot this point in complex plane, plot this point in argand plane. Both are same thing. These are just the terminologies. Okay. Now this terminology, that is conjugate of a complex number, we have already studied, right? Conjugate of complex number we have already studied, right? Let's just officially, like legally study it. So conjugate of a complex number. So any complex number is represented in a form of a plus iota b, right? Conjugate will be a minus iota b. It is denoted by z bar, right? So conjugate of z is what? Z bar. If z is a plus iota b, it will become a minus iota b. So what are we doing? We are just reversing the sign of a plus iota b. We are just reversing the sign of imaginary part. So b minus b. Okay. All right. So yes. So z bar is obtained by changing the sign of imaginary part of z. It is very clear. Okay. So yes. So if there is a point a comma b, okay, this is your z, right? Then conjugate is a comma minus b. This is your z bar. So clearly what we are doing is we are changing the sign of the second element of the ordered pair. So if it is 2 comma 3, it is 2 comma minus 3. And you can also see that we are taking a mirror image of this about x-axis. Okay, just like that. So z bar is actually the reflection of point z in the real axis. We are taking always mirror image. This is a geometrical significance between z and z bar. Okay. Now properties of conjugate. Let us understand the properties. So z you know, z bar you know, a plus iota b, a minus iota b. Now if you one more time take conjugate of this, so what will you do? You follow the same process. If this is minus b, right? Imaginary part is what? Minus b. Now again you change the sign. What will it become? A plus iota b. So if you take one more conjugate of this, you will become back to this. Right? So remember in set theory also a complement ka complement is a only. वैसे z bar ka bar is z. Okay? First property. Second property is if you add complex number with its conjugate, then what will happen if you add these two? Iota b will get cancelled out. So z plus z bar becomes 2a. So that is 2 times real of z. And similarly, if you subtract, you will get, so 2a. If you subtract, you will get 2 iota b. Right? Subtract it. A cancel, iota b minus iota b. So 2 iota b. So basically 2 iota imaginary part of z. That's what you're getting. Okay. All right. Now this is very important. Z bar. Let me show you. Let me show you. Z bar. Multiplication of z with its conjugate. So a plus iota b, a minus iota b will become a square minus iota square b square. Iota square is minus 1, so a square plus b square. Right? So this is what? Real part square, imaginary part square of z, original. Right? So z bar is what? A square plus b square. That means real part of z square, imaginary part of z square. Okay. All right. Now next property, when z and z bar becomes 0, very important property, important alert. When z and z bar becomes equal, this and this becomes equal. A cancel, that means b should be 0. Clearly from here also. Z minus z bar is becoming 0. This is becoming 0, right? If this is becoming 0, that means b is becoming 0. B means imaginary part is 0. Then if imaginary part is 0, then the number is purely real, yes or no? Okay. So if z minus z bar is 0, or you can say z is equals to z bar, very important. Z equals to z bar, directly you have to write. Okay, you have to remember this. This is a condition of purely real. So now, the previous question can be done with this method without even, we don't need rationalization. So this will help us in saving a lot of time. When a number is purely real, z equals to z bar. When a number is purely imaginary means what? Real part 0, that means a 0. That means z equals to minus z bar, or you can say z plus z bar is 0. So whenever z plus z bar becomes 0, the number becomes purely imaginary. Okay. Any doubts? Any problem? Any confusion? Do let me know. Okay, some more properties of conjugate. Okay, now suppose you are having z1 plus z2 as a separate complex number, right? Z is z1 plus z2. There is a new complex number, z1 plus z2, and now you want to take the conjugate of that. Rather than adding, separating real part, don't do that. Just you can do take individual also. So this z1 plus z2 whole bar will become z1 bar plus z2 bar. Okay, all right, clear? This is the first property. Second property, again subtraction may also it will work like that only. Z1 minus Z2 whole bar is equals to Z1 bar minus Z2 bar. Okay, now it is working in multiplication also. That means the conjugate, the bar is separatable. Basically separatable is not even a word, but you can separate the bar. Okay, Z1 Z2 whole bar is Z1 bar Z2 bar. We will use a lot of properties like this. Also, this is very important. Z raised to power n, this is Z cube bar, is nothing but Z bar whole cube. Okay. Next, we are having again division property Z1 Z2. Z1 by Z2 whole bar is Z1 bar upon Z2 bar. Okay. All right. Let's do this question. Let's solve this question. Okay. So let's understand this question first. Let's understand this question first. X plus iota y raised to power 5 is given as 4 plus 5 iota. Correct? And you are looking for y plus iota x raised to power 5. Okay. All right. First thing, okay, if I just look at this and look at this, let us talk about, there is some similarity in these two expressions. There is obviously some differences in these two expressions, right? Power 5 is same. But I can see that here y is having iota, but here y is not having iota, x is having iota. Okay. So to make it similar, if we want to, basically we want to use this to get this, right? This is the question. This is given. Calculate this. That means what? They are saying use this and calculate this. So using this, we want to create this. Agree or not? Okay, ma'am. Now what I will do is, I will actually, because iota is involved with x over here, why don't I introduce iota over here? Okay, so I'll do the first step I have clear in my mind. Let us introduce iota over here. To introduce iota over here, I need to multiply iota power 5 both the sides. Okay, because I want to send iota in this bracket. Iota power 5, 4 plus 5 iota. Okay. Iota power 5 up, let's put it inside iota x plus. So basically what I'm trying to say is, hold on. This is actually iota x plus iota y power 5. Iota x plus iota square y power 5. Iota x minus y power 5 is equals to, now right hand side, iota power 5 is what? Iota. Iota 4 plus 5 iota. This is 4 iota minus 5. Okay, 4 iota minus 5. Okay, now what is difference? What is the similarity? So iota, so we have achieved. We just want plus sign over here. We just want plus sign over here. Okay, so or else, if not plus sign over here, can we obtain minus sign over here? Then if we obtain minus sign over here, what we will do is we'll take minus sign common. Why I am saying this? Because obtaining minus sign over here is much easier because we have a concept called conjugate which we have just learned. Okay, taking conjugate both sides with help. Now taking conjugate both the sides. Taking conjugate both sides. Okay, taking conjugate both sides, what we are going to get is, so this is minus iota x minus y. Sorry, let's do one thing. Let's take conjugate first because we're trying to apply the property. Iota x minus 5 power 5 whole conjugate is 4 iota minus 5 conjugate. So in here, if you take conjugate, this will become minus 4 iota minus 5 because we are reversing what? We are reversing sign of 4. We are reversing sign of whatever which is written with iota, correct? Here, power 5. So now conjugate and 5 are reversible. Iota x minus y conjugate power 5. This is also done, right? We have used that property. Let me just go back. This property. Z power n conjugate will be z bar power n. So again, first take conjugate, then apply the power. So this is minus iota x minus y. Done, conjugate done, power 5 is equals to minus 4 iota minus 5. Clearly minus sign will come out and it will get cancelled out. So iota x plus y power 5 is 4 iota plus 5, my dear students. So clearly the answer is 4 iota plus 5. Easy peasy lemon squeezy, right? Okay. Got it? Clear? Any doubts? Any confusion? Do let me know. Okay. Let us now talk about the next question. Next question says sin x plus iota cos 2x and cos x minus iota sin 2x are conjugate of each other. Then we are looking for the values of x. So again, let's do that. These two are conjugate of each other. So what we will do is, let's take conjugate of this and equate it with this, right? So this is conjugate of this. This is conjugate of this. So basically what they are saying is conjugate of sin x plus iota cos 2x is this, cos x minus iota sin 2x. Yes, correct. So sin x plus iota cos 2x bar will be equals to cos x minus iota sin 2x, correct? This is going to become sin x minus iota cos 2x equals to cos x minus iota sin 2x. Now what you can do is equate these two complex number. That means sin x, and if these two are equal, that means sin x and cos x both should be equal. First thing, sin x should be equals to cos x. Second thing, cos 2x is equals to sin 2x. You need to solve these two and get the answer. Okay. So this is obviously tan x equals to 1 and this is tan 2x is also 1. Right? Tan x equals to 1. Tan 2x is also 1. You know that tan x equals to, so this is clearly equation solving game, right? Tan x equals to 1. So tan x equals to tan pi by 4. So this is x will be n pi plus pi by 4. And second thing will be 2x equals to n pi plus pi by 4. So x will be equals to n pi by 2 plus pi by 8. These two are the two different solutions, right? So now intersection of these two. First intersection second. first intersection second. Intersection of these two will give you the final answer. Okay. All right. Now clearly there is no such intersection between these two. If you take intersection, your x will become phi. Right? Okay. So if I go back, then option D is absolutely right, because it is not possible. Right? It is not possible, because this is saying that your x will be in multiple of pi by 8. This says that x is in multiple of pi by 4. Not possible. Right? Okay. So no value of x will be satisfied in this. All right. Now we are having a very important and basic thing of complex number. Okay. So now whenever you hear a complex number, the very first thing, be it your NCERT, be it your CBSE book, be it JEE Advanced, be it your JEE Main, two things always come hand in hand. Modulus of a complex number and argument of a complex number. Okay. All right. What are these two terms? Modulus and argument. Why are these two terms so important? Suppose if you have to locate me, if you have to know the exact location of mine. So if I tell you that I stay in Indore, so will you be able to locate me? No. Right? And if I only just tell you that I stay in a colony called Gopal Bagh, will you be able to, in whole India and in this whole world, will you be able to locate me? No. You want both. You want city also and you want colony also. Right? Colony and city will actually help you to locate me proper. Now, if any of these two things is absent, suppose I'm just telling you Indore, no, you won't be able to find me, right? And if I just tell you the colony, Gopal Bagh, there are so many colonies in all over India in Gopal Bagh. How will you find me? No. So you want both things. So that's why to know a complex number, to know the exact complex number, you need two things, which is modulus as well, and you need argument as well. Okay. All right. So modulus, first of all, let's understand what is the modulus. So suppose z is equals to a plus iota b is there, and you know that this a plus iota b is actually a point in the complex plane a comma b, right? Now the distance from a comma b, distance from this point from the origin is your modulus. Okay. So two things you need to know. First thing, so basically colony and city. So this is what you're looking for is colony, right? So this is the colony name. If I ask you modulus, that means half information is shared. So distance from origin of this point of this complex number, if it is given, then only half information is shared, because there will be a lot of complex numbers who are, let's say, our distance. Suppose modulus is 1. That means distance from that complex number from origin is 1. Just tell me, how many complex numbers are possible? Infinite possibilities are there. Okay? Infinite possibilities are there. So that is the half thing. Now rest half we will understand. So first of all, let us understand. So x plus iota y, suppose you have a complex number. So point is x comma y, distance from origin will be what? X square plus y square. So your modulus, it is represented by mod z. It is not that mod, that is different. Okay, this is different. Modulus of a complex number is completely different thing, although it is always positive because we are talking about the distance. Mod z is square root of x square plus a square, that is nothing but OP. Okay, that is OP. So mod z represent distance from the origin. Now this is also a very important thing. Okay, please keep that in mind, that mod z is actually distance between z, that is z point, and origin 0, 0. Okay. All right. So mod z is that, this is your modulus. Okay. And now whenever you have two points in the complex plane, right? This is x1 comma y1, that is x1 plus iota y1, x2 plus iota y2. Now if you're looking for distance between PQ, so what will you say? PQ is mod z1 minus mod z2. So mod z1 minus mod z2 represent what? Distance of z1 from z2, or you can say distance from z2 from z1. Okay. So again, if you talk about that coordinate geometry, the distance between P and Q will be what? You know that, right? This is going to become square root of x1 minus x2 whole square plus y1 minus y2 whole square. That's it. Okay, let us have a question, then you will understand that what I'm trying to say. If the complex number z satisfying z plus mod z is equals to 1 plus 7 iota, find the value of mod z square. Okay, find the value of mod z square. So how will we do that? First of all, let's assume that z is nothing but x plus iota y. Mod z square is what? X square plus y square is what you're looking for. Okay. Now let us talk about this. We need to solve this, correct? Z is your x plus iota y plus mod z is what? Square root of x square plus y square. Mod z is always a real quantity. Obviously, it's a distance. This is 1 plus 7 iota. Now, two things are equal. Just compare. X plus root x square plus y square is equals, plus iota y is equals to 1 plus 7 iota. Okay. So now y is equals to 7. Because this is imaginary part equal to imaginary part. What is real part? This whole thing is real part. That is equals to 1. So x plus square root of x square plus y square, that is 7 ka square, is equals to 1. So this is actually square root of x square plus 49. You have to solve it. Is equals to 1 minus x. Squaring both the sides. X square plus 49. Squaring this. Okay. Squaring this. X square plus 1 minus 2x. Clearly x square cancel. So this is going to become, x will be minus 24. So now you have got x and y, just this is minus 24 square, this is 7 square. So this is going to become 576 plus 49. So this is 625. So correct answer of this question is 625. Have a look. Let me know if you have any doubts in this. Okay. Modulus clear? Perfect. Okay. Now we are having properties of modulus. Okay, let's talk about properties of modulus. Okay, so properties of modulus may, let us first understand that the geometrical significance. Let us have a look at the geometrical significance. If z is equals to x plus iota y, then this is the point x comma y, right? This is the complex number x plus iota y, and its conjugate will become what? X minus iota y. Okay. Now if you take modulus of z and if you take modulus of z bar, just tell me that what will be the modulus. So see, x plus iota y, distance from origin of x comma y will be the same as distance of x minus iota y. What does that mean? That modulus of a complex number is equals to modulus of its conjugate, right? So this is one property. And also one more thing, minus z. Minus z, that means you are actually, so minus z will be this. Minus x minus iota y. This is also the same, right? So this is also same distance away from the origin. So modulus of minus z, distance of minus z from the origin is also the same, right? So this is the very first property. Mod z mod z bar and mod of minus z. All these three things are equal. The distances are equal. This is the very first property of modulus. Okay. Second property, let's talk about second property. So second property is very easy. If your complex number is 0, that is 0 plus 0 iota, then distance of 0 plus 0 iota from 0 is what? 0 only. So mod z is becoming 0. And one more thing, if anybody is giving you mod z is 0, what does that mean? If mod z is 0, that means your z is 0. If mod z is 0, that means your z is 0. Okay. Now this is a very, I just do not want to write very. I just want to write in red color, important alert for JEE Main and Advanced both. Important and alert. Okay. Important alert. Important alert. Okay, so what is so important about this property? Z bar. So if you multiply, we have already done that, by the way. We have already multiplied a complex number with its conjugate. The moment you multiply a complex number with its conjugate, x plus iota y and x minus iota y, this is your z, this is your z bar. If you multiply them together, z bar is equals to what? X plus iota y, x minus iota y will be x square plus y square. Okay. And x square plus y square is nothing but square of the modulus. Yes. So z bar is equals to mod z square. Very, very important. Okay. I will tell you while solving the problem when exactly to use it. There are specific situations when we use this property. Right? This is actually widely used. Majority of the questions you will be able to solve by this property only. Okay. All right. Perfect. Now 1 upon z. If you write 1 upon z, so clearly 1 upon z, here can you calculate the value of z? Z is nothing but, ma'am, mod z square by z bar. So this z is replaced by mod z square upon z bar. Okay. So this is also this is also we can write actually, है ना? So I mean property is this only, but this is how you calculate the value and write. Okay. Now one very important thing, whenever you see mod z is equals to 1, 90%. Whenever you see mod z is equals to 1, that means 90% there are chances this property will come into the picture. Z bar is equals to mod z square. That means in this case z bar will be what? 1 only. So z bar and z will be reciprocal of each other. Okay. All right. Clear? Properties of modulus. Okay, so basic again, the properties we have studied in conjugate, na, same are with modulus. So remember we were studying Z1, Z2 bar is what? Z1 bar, Z2 bar. So here also Z1, Z2 mod is Z1 mod, Z2 mod. You can just separate the modulus. Similarly, in general, if there are multiple complex number in multiplication, you can just separate them out. Same properties, remember we studied in conjugate, z cube bar is equals to z bar cube. So basically we are interchanging the order of power and conjugate. Here also we are doing same thing. First there is power and then modulus. So we can just shift this power later on. First take modulus, then power, doesn't matter. Okay. And same thing, the conjugate property. So mod z1 by z2 is mod z1 by mod z2. Same property in multiplication and in division. Right? Okay. Let us do one question and then understand that how many properties have we understood. Okay, z1, z2, z3 are complex numbers such that mod z1 and mod z2 are given as equal. Okay, and mod z3, okay, mod z1, mod z2, mod z3 all are equal. And okay, hold on, they are saying mod z1 is also 1, mod z2 is also 1, mod z3 is also 1. That is one separate thing. And this is one another thing, 1 by z1 plus 1 by z2 plus 1 by z3 is equals to 1. Then we are looking for this. I have already told you, whenever any modulus becomes 1, then remember this property, z1 bar is your 1, z2 bar is again 1, z3 bar is again 1. Okay, so 1 by z1, if you just shift this z1 over here, so z1 bar will become 1 by z1, z2 bar will become 1 by z2, and z3 bar will become 1 by z3. So here 1 by z1 will be replaced by z1 bar, this is z2 bar, z3 bar is equals to 1. Now remember the reverse property of conjugate. These individual bars can be applied as the overall bar. And remember one more property of modulus we just studied. So mod z is equals to mod z bar. So whenever there is bar, you can just remove that bar. So this bar is removable. So mod z1 plus z2 plus z3 is what? Tell me. 1 only, right? So this is 1. Okay. Clear? Any doubts, any confusion? Do let me know. All right. Next. Let us have a look at this question now. Okay. Let z be a complex number. Hold on. Let z be a complex number such that mod of z minus iota is equals upon mod of z plus 2 iota is 1. Mod z is given as 5 by 2. Then the value of mod z plus 3 iota. Okay. So this is given. Okay. This is what we need to solve. What we will do is mod z minus iota upon mod z plus 2 iota, right? So this will be mod of z minus iota upon mod of z plus 2 iota. What did I do? I just separated the modulus and now it is easy to cross multiply. Mod of z minus iota is equals to mod of z plus 2 iota. Okay. All right. Now, here we can square both the sides. Yes, we can square both the sides. Right? We can square also both the sides, and also what we can do is we can just check that if z is equals to x plus iota y, we only know this thing, right? So we can just plug in x plus iota y in place of z. X plus iota y minus iota mod is equals to x plus iota y plus 2 iota. So, okay, so x, now we have just put the value of z, x plus iota y here and here. Okay, separate the real part. So this is x plus iota times y minus 1 modulus is equals to x plus iota y plus 2 modulus. Understand, moduluses are equal, not the complex numbers. No. Complex numbers are not equal. Do not do that. X is equals to x, y minus 1 is equal to, no. Take modulus. Modulus of this, tell me. Modulus of the left hand side will be square root of x square plus y minus 1 whole square is equals to modulus of right hand side will be again x square plus y plus 2 whole square. Clearly, this and this are getting cancelled out. X square also gone. Y minus 1 whole square is equals to y plus 2 whole square. Square is also gone. Y minus 1 is equals to y plus 2, or y minus 1 is equals to minus y minus 2. So 2y is equals to minus 1, y is equals to minus 1 by 2. Okay, and y is equals to y. So here though no value of y is coming, but y is minus half is coming over here. Okay, y is coming out as minus 1. One more information is given, mod z is equals to 5 by 2. So mod z is 5 by 2 means x square plus y square is equals to 25 by 4. Y is minus half. So this is x square plus 1 by 4 is equals to 25 by 4. So x square will be equals to 6. X is nothing but plus minus root 6. Okay. As per the question, what are they asking? The value of z plus 3 iota. Okay. Mod of z plus 3 iota. So basically, there are two ways to go about it. Let me just introduce it. First is also, this is x plus iota y plus 3 iota mod, right? X plus y plus 3 iota mod. Then x is what again? Plus minus root 6 plus y plus 3. 3 minus 1 by 2 iota mod. So this is going to become 3 to the 6. So this is 5 by 2 iota root 6 plus minus mod. So mod will be equals to root 6 ka square 6 plus 25 by 4. 6 4s are 24. So this is root 49 by 4. 7 by 2 is the final answer of this question. So let us have a look, and option B is absolutely right. Okay. All right. So what did we do? We just applied one property of modulus, separated, cross multiply. Then we realized just put x equals to z is equals to x plus iota y. Trust me, majority of the easy questions, the NCERT based questions, will be done by just putting z is equals to x plus iota y. And some questions from JEE Main also, only this thing. Just put the moment you see z, put x plus iota y. Okay, right? Now x plus iota y, so take modulus, separate the real and imaginary part, separate real and imaginary part, take modulus both the sides and obtain the condition. Condition is y is equals to minus half. From here, y is equals to minus half. Now plug in mod z is equals to 5 by 2. That means x square plus y square is equals to 5 by 2 square. Put y, get x. Once you got x, now you're looking for this again. Same, x plus iota y you put, then figure out the modulus, plug in the values, get your answer. Okay, so this was that question, and now let us move on to the next problem. Okay, so I have told you that a lot of problems are done by this very property, which is z bar is equals to mod z square. Hero property of modulus. Hero property of modulus. Sorry, hero property of complex numbers. Hero property. Okay, Vera level property. Very good property. Okay. In here though, you can see that how many times you're going to put x plus iota y. There is no sense, right? Okay. And also there is modulus also involved. And also z1 bar, so many bars also are also involved. So that's why I'm trying to tell you that z bar is equals to mod z square is that property which we are going to use over here. So clearly this is again what? Something mod of something square. We are going to apply the reverse property. Mod of z square is z bar. Mod of this square is what? Z. That means you just write things as it is. Z. Okay. Remove modulus. No need for modulus, because mod of anything square is that thing and take bar of that. This again, mod of anything square is what? Same thing, and now this time z1 minus z2 bar is equals to k times, again 1 minus z1, mod z1 square is z1 bar, 1 minus z2 bar. Done. Right? Okay. Now let us just talk about this one by one. So 1 minus z1 bar z2. And this will be what? Now again, conjugate property. Okay, so bar will be over 1 and bar will be over here. Conjugate of 1 is 1 only. Minus. Conjugate of z1 bar is z1. This is z2 bar. Minus. z1 minus z2. This is z1 bar minus z2 bar. Equal to k times 1 minus z1 z1 bar. So now multiply. Or, okay, let's multiply 1. Okay, 1 minus z2 z2 bar minus z1 z1 bar. Okay, and and then plus z1 z1 bar z2 z2 bar. Perfect. Okay, now let's talk about this. Let's just multiply this as well. 1 minus z1 z2 bar minus z1 z2 plus again z1 z2, sorry, z1 z1 bar z2 z2 bar minus z1 z1 bar, okay, then plus z1 z2 bar, correct, then this plus z2 z1 bar, and last this is plus with minus, so this is minus z2 z2 bar is equals to k times whole of this thing. Okay, now perfect, this is your left hand side. Okay, now clearly this is, let's try to match, or let's just try to cancel also if it is happening. z1 z2 bar, z1 z2 bar, it is getting cancelled out. z1 bar z2 is getting cancelled out with this. Okay, and now we are having, okay, so we are having, yes, let's just club 1. Now it is all 4 things. Okay, 1, and also this is z1 z1 bar. Okay, so 1 minus z1 z1 bar, this thing, minus z2 z2 bar, and plus z1 z1 bar z2 z2 bar. This is your left hand side is equals to k. Can you see a similar thing? Same thing we have to copy paste. 1 minus, see, z1 z1 bar minus z2 z2 bar plus z1 z1 bar z2 z2 bar. Clearly left hand and right hand side are same, so k should be equals to 1. So in this scenario k is coming out as 1. Okay, k is coming out as 1 in this particular scenario. Have a look and let me know about this property. So the whole sole purpose is to make sure that you understand this property nicely, because we are going to use this property a lot of time in PYQs also. Okay, now next we are going to move on to argument, right? Because I already told you for a complex number, modulus is important 50%, argument is important 50%. What is argument? Okay, to locate a complex number nicely, you need 2 things. For example, we have studied this. To know a straight line equation, you need point and the slope. Same thing, na? To understand a complex number, you need what? You need modulus, that is distance from the origin, and the angle as well. Argument is angle, right? So, right. So, suppose we have a complex number a plus iota b, right? A plus iota b is like that. And now, if you join that point P from origin and the angle over here, right? OP makes an angle of theta with the positive real axis. So theta is called argument, or you can call it as amplitude of complex number, right? So it is written down as arg z, and that is your theta. Okay. So in this case, when your complex number lies in the very first quadrant, it is so obvious that your tan theta is b by a. It is very simple, right? First case is that only, right? That your tan theta is b by a. But if your complex number gets shifted to the second or third or fourth quadrant, then what happens? Your angle becomes changed. Basically, you have to think about plus sign, minus sign, pi plus, pi minus, that we will study. Okay, but if it is in first quadrant, if a and b both are positive, then it is very simple. Okay. Now, what is the difference between amplitude and argument, or what is the difference between principal argument? Okay, so principal argument, basically the angle can be anything. So if I say 30 degree, it's same as your 360 plus 30, that is 390. If I say 30 degree, it will be same as 390 degree. It will be same as 720 plus 30, that is 750 degree, right? Okay. So, but principal argument has a range fixed over here. Here theta is lying between minus pi to plus pi, where pi we are including but minus pi we are not including. Okay. So 0 to pi, you know that, see what is happening, 0 to pi and 0 to minus pi, right? So we are covering whole circle. It's just that 0 is included, pi is included. So this position is done now, because if we include minus pi, then minus pi is also this, right? If so, there should be a unique principal argument. The whole sole purpose is there should be a unique value. Nobody should come that, okay, pi is the principal argument. If I'm saying, then somebody else will come, minus pi is also argument. I'll say yes, minus pi is also getting satisfied. Right? So that's why we have excluded minus pi. We have included pi. Both are having same position. That's why. Okay. Now how to, so this is the range of principal argument. Okay. Now argument Z in general will be principal value only. As per the question, if nothing is mentioned now. So if they are asking argument of Z, find argument of Z. So you will only focus on principal values. Okay. Principal values, that means you have to find an angle which is lying between minus pi to pi. Okay. So, but general argument, if the range is not considered, then you just have to find theta, that I told you, 30 degree, 360 plus 30 degree, same thing. So again, so theta plus 2n pi, general argument. Okay. Same position. See, I told you. Theta and 2n plus theta. Did you see? Full circle, theta and 2n plus theta again. Okay. All right. Now, one very interesting thing before we proceed how to calculate argument. Argument of 0 plus 0 iota is not defined. Argument of 0 plus 0 iota is not defined. Think about it. If it is lying here only, it has no direction, right? It has 0 modulus. So angle of a point with origin doesn't make any sense. So it is not defined. Now how to find out principal argument? Let us understand. So suppose case number 1. Case number 1 says that both A and B are positive. Okay. Both A and B are positive. Then it is very simple that tan theta is equals to B by A. We don't have to worry about this. Tan theta will be equals to B by A. So tan inverse B by A will be your argument. But when your A comma B shifts in the second quadrant, what does that mean? That your A becomes negative. This time your A becomes negative. That means X coordinate, if I just talk about the coordinate geometry, X coordinate becomes negative and Y becomes positive. So this is your theta. Okay. This is your theta. So now this angle you want to calculate, and you know that this angle is what? So this angle will be again that thing which is alpha. Let us consider it as alpha. So this angle is what? Tell me. Tan alpha is equals to B by A. And we are only talking about the positive values, B by A. Tan B by A. We are looking for what? This angle. So obviously alpha we know, theta we want to know. So obviously we need to subtract what? So this will be what? Pi minus alpha. So basically your final answer will be pi minus tan inverse B by A. And obviously do not consider sign of B and A. Direct you can write this formula. Whenever you see A is negative, pi minus tan inverse B by A. Now when your A and B shifts in the third quadrant, if it is both are negative, then you are looking for this angle. Then your angle will become negative if you talk about principal argument, right? Because see, somebody can say that, ma'am, this also can be the angle. Yes, this obviously can be the angle, but we are looking for principal argument, right? Otherwise, pi plus tan inverse B by A I would have written, but no. So this is again alpha, and you know that, so this is alpha. You know that this angle is negative. So again, same thing, theta will be, right? Theta will be, if you find theta, pi minus alpha. But because theta is having clockwise direction, that's why it is negative. So this is going to be alpha minus pi. Alpha minus pi, that means it is going to become tan inverse B by A minus pi. Okay. And in the fourth quadrant, very easy. Minus of tan inverse B by A, that's it, because the angle is negative. So minus alpha minus tan inverse B by A. All the four angles right here. Here the angle will be tan inverse B by A. Okay, here the angle will be tan inverse B by A with a negative sign. When your only y is negative. When x comma y both are positive, x positive but y negative. Here x negative, y positive. So pi minus alpha. Here both x comma y are negative. So this is pi minus tan inverse B by A, tan inverse B by A minus pi. I hope that this is very easy. Let us try calculate one by one values. But before that, let's take the exceptional cases. Suppose you have a complex number whose real part is 0 and imaginary part is positive. That means 0 comma b is positive. It will lie here, okay, on imaginary axis. So what will be the argument? Think about it. So argument is always considered from the x-axis, correct? So it is going to become pi by 2, right? This is pi by 2. So in this case, the argument will be pi by 2. Z lies on positive imaginary axis. So this is pi by 2. But if your imaginary part B is negative, that means the point lies over here. So this will be your argument. Minus pi by 2 in this case will be your argument. Okay. Minus pi by 2. So basically, if your number is, suppose argument of, let's say 2 iota, if I say, that means real part of this complex number 2 iota is 0. Imaginary part is positive. So this is pi by 2. And if I ask you argument of minus 2 iota, automatically you will say minus pi by 2. And suppose if you are having any complex number which is having 0 imaginary part, suppose 2, 3, 4, so it will obviously lie here, and this will be the complex number, and the angle of this OP from real axis is 0 degree. So if A is positive, B is 0, then angle is 0. And if this time B is again 0, but this time you have a negative number on real axis, that means suppose I ask you what is the argument of minus 2. You will say the argument will be pi, not minus pi, pi. Minus pi is not at all allowed. This is pi. So argument of 2, tell me, just 2 is 0, but argument of minus 2 will become pi. Okay, these are the exception things. Okay, so argument of purely real number is either 0 or pi. Argument of purely imaginary number is pi by 2 and minus pi by 2, depending upon the sign of imaginary number. One by one we will tick solve this, figure out the amplitude, or you can say argument of this. Okay. All right. Find the argument of the following: minus 1 minus iota. So again, which quadrant? Before jumping on to anything, figure out the quadrant. Minus 1 minus iota, third quadrant. Third quadrant ka angle is tan inverse y by x, so 1 upon 1 minus pi, alpha minus pi. And no need to consider the sign because sign here we are already considering. Pi by 4 minus pi. So this is minus 3 pi by 4 is the answer of first thing. Clear? 1 minus root 3 iota. So this is tan and so which quadrant? Fourth quadrant. Fourth quadrant very easy. Angle is minus tan inverse. Root 3 by 1. So 60 degree minus pi by 3 is the answer. Okay, first. This minus 7. So the minus 7 is a purely real number. It lies on the real axis. Minus 7. So angle is pi. We have just studied this. 4 iota. Purely imaginary and lies on positive imaginary axis. Pi by 2 is the final answer. Okay. Alright. I hope that now the argument you are able to find it out. Okay. Chalo. Let us talk about this question which asks us to calculate modulus and argument of this. Okay. We have to be very careful, right? Because modulus is always positive. You cannot just blindly give any answer which might be a negative number. Okay, especially when trigonometric expressions comes into the picture. Okay, so here alpha is lying between pi by 2 to 3 pi by 2. That means pi by 2 is here, 3 pi by 2 is here. Second quadrant, third quadrant. Okay, second quadrant, third quadrant. Okay, find the modulus and argument of this. Okay, so 1 plus cos 2 alpha plus iota sine 2 alpha. Modulus. You know how to calculate modulus? Modulus of z equals to mod z. Let us say this is your z, correct? Square root of 1 plus cos 2 alpha whole square plus sine 2 alpha whole square. Okay, so 1 plus cos 2 alpha whole square. So 1 plus cos 2 alpha is 2 cos square alpha. So this is 4 cos power 4 alpha. And this is sine 2 alpha, so sine square. Or rather, we can do one thing. Hold on. Let's not open it. Let's open the square only. 1 plus cos square 2 alpha plus 2 cos 2 alpha plus sine square 2 alpha. Okay. Cos square plus sine square will be 1. So 1 plus 1, 2. 2 plus 2 cos 2 alpha. If you take 2 common, 1 plus cos 2 alpha is what? 1 plus cos 2 alpha is what? 2 cos square alpha. If you take out the square root, so 2 2s are 4, so it is going to become 2, but mod of cos alpha will be there. Mod of cos alpha. 2 mod cos alpha is the modulus. So modulus is coming out as 2, but mod of cos alpha. Okay. Now cos alpha, second and third quadrant. Cos alpha is negative, so you cannot give this answer. So which answer you should give? Modulus will get open. So this is fine. This is fine. 2 cos alpha is fine. 2 mod cos alpha is fine. But answer cannot be 2 cos alpha. It will be minus 2 cos alpha. Either this or this. Because both are positive. I will tell you. 2 mod cos alpha. This is a positive quantity, right? And now minus 2 cos alpha. You are saying na cos alpha is negative. So if cos alpha is negative, I have applied one negative sign so that finally if you put the value, eventually cos alpha is negative, minus minus positive, 2 minus 2 cos alpha will be a positive quantity. But if you write 2 cos alpha, it will be absolutely wrong because 2 cos alpha in itself is negative. So 2 cos alpha is a negative quantity, modulus is a negative quantity. Okay. All right. Clear. Now argument. For argument, let's do one thing. To understand the argument, let's do one thing. This is actually 1 plus cos 2 alpha is actually 2 cos square alpha plus iota sine 2 alpha is what? 2 sine alpha cos alpha. Correct? I can take 2 cos alpha out. 2 cos alpha I have taken out. So this is cos alpha plus iota sine alpha. Okay? All right. Cool. So this thing is a negative quantity. Yes, ma'am. What about cos alpha? Cos alpha is again a negative quantity. What about sin alpha? Now sin alpha, we don't know. Sin alpha can be positive, can be negative. Right? So now, basically what I'm trying to say is, this is a negative thing. Negative, negative, positive. That means your x is positive. X is positive, that means point lies either in first quadrant or in second quadrant, because sin alpha can be in second or third quadrant. No? So it depends on sign. Okay, so if it is in first quadrant or if it is in fourth quadrant, you know that the angle will be what? In first and fourth quadrant, you know that angle will be plus minus tan inverse y by x. So tan alpha. Okay, tan inverse tan alpha will be the answer. Plus minus tan inverse tan alpha. Depends on where the sign lies. Okay, because negative, and then if it is positive, oh, hold on. Let's do one thing. Because we know 2 cos alpha is negative, why don't I do one thing? I take minus sign common. Now minus 2 cos alpha. This one is positive, right? This is minus cos alpha minus iota sin alpha. Correct? Now, what about minus? So this is positive thing. Let's forget this. Now this is your a plus iota b format. Just tell me, A is positive. A looks like it is positive. Yes, A is positive, ma'am. What about B? B is what? Minus sin alpha. So now minus sin alpha depends. It can be positive, it can be negative, right? So that's why if A is positive, again same thing, we are stuck in same thing. So the argument of this will be plus minus tan inverse tan alpha. Okay, and alpha is belonging to pi by 2 to 3 pi by 2, so we cannot remove this tan inverse tan alpha. We cannot remove this. Okay, we cannot write just plus minus alpha. Okay, all right. Now there are different ways to represent a complex numbers, right? First way we have already seen, a plus iota b, x plus iota y, the simplest form, the algebraic form. Okay, so Cartesian form or algebraic form or geometrical form, all the three things are conveying the same thing. That means a plus iota b. It is very clear that this can be plotted on the argand plane as well. A comma b is the point. That's why this is a geometrical form as well. It is a very basic form. You just know the point and you just know the complex number, exact complex number, right? Z is equals to a plus iota b. We know that, we have already studied that real part is a and imaginary part is b, and in here you also know that you can plot this point on the argand plane, or you can say complex plane, right? Yes, Okay, and about this you also know one thing, that the conjugate of a plus iota b is a minus iota b. The modulus of this is mod z is equals to square root of a square plus b square, and argument of this depending upon the quadrant, we have learnt this. So this form we in and out know this particular form, so I'm not gonna spend more time in explaining what is Cartesian, what is algebraic form. Right now the next form is polar form, or you can call it as trigonometric form, that is r cis theta. Ma'am, what are you saying? R cis theta. Yes, r cos theta plus iota sin theta. So this complex number a plus iota b can be expressed in a form which is this, that is, you clearly can see r cis theta, or you can call it as r cos theta plus iota sin theta. Correct? Okay. What is r? What is theta? So r is simply your modulus, that is square root of a square plus b square is r, and cos theta plus iota sin theta. So cos theta, theta over here is nothing but argument. Okay. So what if I tell you, I'll give you a complex number, very basic complex number, let's say 1 minus iota. Can you convert this complex number into its polar form? We will do that. Okay, in this particular topic we will do the conversion, interconversion between the various forms. So suppose algebraic form is given, you have to calculate polar form. Polar form is given, you have to calculate algebraic form. Okay, so one by one we will do it. Correct? So clearly I already told you now, to know a complex number, either you know the exact point a comma b, then so it's gone, then you don't need anything. But if you don't know a comma b, then what do you need? You need r, that is modulus, and you need theta, that is argument, that I already told you, that two things are very important to understand the complex number, to know the exact complex number, that is r and theta. Okay, all right. So r cis theta, so whenever I say r cis theta, that is r, that is modulus multiply cos theta plus iota sin theta. We will use this form a lot of time, very frequently used form. Okay, and also whenever you see that conjugate of z, so conjugate of z, obviously basic definition, whenever you understand conjugate, conjugate means just change the sign of whatever which is written with iota. So iota sin theta, so minus sin theta, so this is z bar or conjugate of z. Okay, all right. Now one more thing, can you just tell me one thing, this cos theta minus iota sin theta can also be written down as cos of minus theta plus iota sine of minus theta. Why I am doing that? Because I want my complex number, my polar form to be in standard form, and standard form suggests that r should be there, cos theta plus sine should be there, plus iota sine theta should be there. Okay, so right, so I changed the angle as per this sign, so this sign will go inside, so this is minus theta for consistency, because argument cannot be theta and minus theta at the same time. So cos of minus theta, you know, cos theta. So if I write cos minus theta, it will not get affected, right? So r cis theta, r cis minus theta will be the final answer. Okay, all right. So clearly, if argument of z is theta, then clearly argument of z bar will become minus theta, right? Suppose it is given that argument of z is given as theta. So argument of z bar is what? Minus theta. Right or wrong? Yes? Okay. Now just tell me, cos theta plus iota sin theta is written, and you have to figure out the modulus of it. You know how to calculate modulus. Square root of real part square plus imaginary part square. So this is going to be 1. Okay, this is very interesting. So suppose only cis theta is given, then you can just clearly see that, okay, modulus of cis theta complex number is what? 1. Okay, and also modulus of cos theta minus iota theta, that means modulus of conjugate of this will also be 1. There is a property also. Mod z and mod z bar both are same. So mod z is 1. So mod z bar is also 1. Right? Okay. Now let us talk about how to calculate, how to convert the forms, how to write in polar form. Let us just do some basic problems to understand, to get a better understanding that how a polar form looks like. Okay. So it is given that mod z is 2. That means if complex number I have assumed it is r, cos theta plus iota sin theta, then I can simply write it as z equals to r. So that is 2 cos theta plus iota sin theta. So theta is pi by 4. See, r is 2 and theta is pi by 4. Whenever you know r and theta, no, then you're sorted. Then you can write polar form, then you can write algebraic form, then you can write any form. So cos pi by 4 plus iota sin pi by 4. Correct? This is your z. Okay, in polar form. In polar form. In algebraic form, z will be equals to 2 1 by root 2 plus iota 1 by root 2. So this is z and root 2 plus iota root 2. Correct? If you rationalize, this is z. Z bar will be what? Root 2 minus iota root 2. This is your z bar. That's what they were asking. Right? So z bar is coming out as root 2 minus root 2. I hope that this is clear. Okay. All right. Now let us do one question which says that we have to convert the algebraic form of a complex number into polar form. So, okay. Cool. So if z is minus 1 minus iota root 3 and you need to express z in polar form, then you know that you need r and theta. Just these two things and you are done. R. How to calculate r? So r is nothing but mod z, and you can easily calculate mod z from here. Square root of minus 1 ka square is 1. Square root of minus root 3 ka square is 3. So this is coming out as 2. So clearly 2 cos of theta plus iota sin of theta. Now we are here to calculate the argument. Okay. So argument के लिए, argument of z. See, both x and y or both a and b are negative. That means that minus 1 comma minus root 3 lies in third quadrant, and in third quadrant the angle becomes alpha minus pi. In third quadrant angle becomes alpha minus pi. Right? So alpha is what? Tan inverse root 3 by 1 minus pi. So this is pi by 3 minus pi. So this is going to be minus 2 pi by 3. This is your argument. Minus 2 pi by 3. Minus 2 pi by 3. Correct? Okay. So this is your polar form. This is simply your polar form, right? Polar form is what? Now 2 cos 2 pi by 3 with a negative sign, and you can write this as well. 2 cis minus 2 pi by 3. This is also acceptable. Okay. So this is how you convert the forms. Now I feel that you're comfortable in converting the forms. Okay. Now there is the third form, my favorite form, Euler's form. Euler's form. Euler's, it looks like it is the Euler. Euler is a mathematician, right? But we pronounce it as Euler's form. Okay. Euler's form mein, again, same thing we need to understand, that we have to write, we have to know both same things. R, that is modulus, and theta, that is argument, right? So Euler form says that again, this is the algebraic form a plus iota b, and it is equal to the trigonometric form r cos theta plus iota sin theta. Now the polar form will be z is equals to r e raised to power iota theta, right? So this is r. This cos theta plus iota sin theta is e raised to power iota theta. Okay. So e raised to power iota theta is given by this. Cos theta plus iota sin theta is nothing but e raised to power iota theta. Okay. Where theta is what? You know, argument of z. Okay. So let us assume that if theta is pi, then what will happen? So if theta is pi, so e raised to power iota pi. Cos pi is minus 1 and this is 0. So e raised to power iota pi will become what? Minus 1. This is the most beautiful equation of mathematics, which involves 5 things which has no correlation among themselves. Let me tell you. E, irrational number. Non-terminating, non-repeating, 2.71, da 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 da. Okay. Power, iota, imaginary number. Pi, 3.0 pi. Let me flaunt my tattoo. Pi. Okay. Pi. Right? E raised to power iota pi. Can you think? Can you think? Can you think this in your wildest dreams? That combination of these three things, e iota pi, will be equal to -1. Right? So how many symbols? 5 symbols are there, but there are 3 things which are which has no correlation among themselves. E iota pi. These 3 things are those things. 2 are irrational and 1 is definitely imaginary. And if you do the math, you will realize that -1, a simple -1 is coming out. That's why it is called as most beautiful equation, right? Okay, you Google it, you will realize most beautiful equation of mathematics. Okay, all right. So e raised to power iota theta is cos theta plus iota sin theta, right? What if I just replace theta by minus theta? Theta by minus theta. So e raised to power minus iota theta. Cos minus theta is cos theta only. Sin minus theta is minus sin theta. Okay, all right. So it is going to become what? Again, so this is e raised to power iota theta. This is e raised to power minus iota theta. Okay, if you add these two, r, you can easily remove this. R is not here. No need, not needed. But yeah, if you add these two, what will you get? E raised to power iota theta plus e raised to power minus iota theta is equals to 2 cos theta. So 2 is by division. So e raised to power iota theta plus e raised to power minus iota theta by 2 is cos theta. By the way, cos theta is a real thing. And if you subtract these two equations, so cos theta is getting cancelled out. So 2 iota sin theta will come. So 2 iota sin theta or upon 2 is equals to, as now this is imaginary. Okay, just for the reference, we will use it. You will understand that, okay, cos theta is this and sin theta is this. Okay, now let us understand that why Euler's form is my favorite form. Okay, so whenever you see any complex number, you can see complex number here, and there are higher powers on the complex number. Power 6 is written over here, power 6. Always think about, do not even think of solving this in algebraic form. Whenever you got the higher powers of any complex number, trust me, just remember your Euler's form. Your life will be much easier. Trust me, I will show you. Convert 1 plus iota 3, 1 plus iota root 3, right? Let us assume this is your z0, z1 is this, right? So now if you want to express in Euler's form, you need r. Clearly the r is equals to square root of 1 square plus, so this is 4, r is 2, z1, right? And what about theta is what? Tan inverse root 3 by 1, so tan inverse root 3 is equals to, so theta will be pi by 3. Okay, so this thing is equals to r e raised to power iota theta. So this is going to become z1 is going to become r 2 e raised to power iota pi by 3. This is your z1. Similarly, if you talk about the z, okay, so let's talk about z2 now. z2 is equals to 1 minus iota root 3. Correct? Now again, this will become what? Okay, so this is lying in which quadrant? X is positive but y is negative. Okay, x positive 1 and minus root 3, y is negative. So the fourth quadrant. So minus pi by 3 and r is 2 only. So this is 2 e raised to power iota minus pi by 3. Okay, so now that you have got z1 and z2, so this is z is written down as z1 power 6 plus z2 power 6. Correct? So this is going to become 2 e raised to power iota pi by 3 power 6 plus 2 e raised to power minus iota pi by 3 power 6. Okay, all right, so this is going to become 2 power 6. You can easily take outside. This is e power now 6 by 3. Okay, 6 by 3 is what? 2 e raised to power iota 2 pi plus e raised to power minus iota 2 pi. Now you know e raised to power iota theta is what? Tell me. E raised to power iota theta. Theta is 2 pi. E raised to power iota theta is cos theta, cos 2 pi plus iota sin 2 pi plus cos minus 2 pi plus iota sin minus 2 pi. Okay. 2 power 6 is already outside. 2 power 6, which is 64. Cos 2 pi is 1, sin 2 pi is 0. Sin minus 2 pi is also 0. Cos minus 2 pi is also 1. 1 plus 1, 2. So finally you are getting 128 as the final answer of this question, right? So 128. Yeah, I guess the modulus of z itself is coming out as, so z is coming out as 128. So mod z is also what? 128 only, right? Mod z is also 128 or 2 power 7. Okay, all right. Shall we move on to the next problem? Okay, all right, perfect. Now z is equals to minus 2 e raised to power minus iota pi by 3 is given. Which of the following is true? That's what they are asking. Okay, all right. First of all, mod z, they are asking in option A and B clearly. Mod z cannot be a negative thing. Mod z will always be a positive thing. Okay, so clearly this z, the format of z is wrong. We can't write this is r and this is the thing. No, we can't do that. Hold on, let me just show you. Minus 2 e raised to power minus iota pi by 3 is what? Cos minus pi by 3. That is cos plus pi by 3 only. Minus iota sin pi by 3. Are you getting my point? Yes, because see, e raised to power minus iota pi by 3. Cos of minus pi by 3. Which is what? Cos of minus theta is cos theta only. Right? Then plus iota sin minus pi by 3. Now sin minus theta. Minus sign will come out. That's why a negative sign you're seeing on here. And now this negative sign will go inside. So 2 minus cos pi by 3 plus iota sin pi by 3. Okay, so this is your r. But what about this? This should be, forcefully it should be cos theta plus iota sin theta. It cannot be. You have to make r positive, that is first thing. And now you have to make this in format of cos theta plus iota sin theta. So what you can do is, you have multiple options. First option is, you just convert it into algebraic method. Minus cos pi by 3 minus cos 60 degree, so minus half plus sin 60 degrees iota root 3 by 2. Correct? Now, clearly, x is negative, y is positive, second quadrant. Pi minus alpha is the angle. Pi minus pi by 3, 2 pi by 3. So actually it is coming out as cos 2 pi by 3 plus iota sin 2 pi by 3. Because cos 2 pi by 3 is actually minus half. Sin 2 pi by 3 is plus root 3 by 2. So the argument, if you want to calculate the argument, it is 2 pi by 3. Option D is right and option C is wrong because it is not in fourth quadrant. Understand? No, it's not in fourth quadrant. It's in second quadrant. Okay. So this very good example to understand the basics, because in JEE Main usually people make this mistake. People do not understand if a format is given. They miscalculate the modulus, and more importantly, miscalculation of argument is quite popular these days. Every other student is miscalculating argument, making mistake in calculation of the argument. Okay. All right. Okay. Now let's talk about properties of argument. Okay. So we discussed properties of conjugate. We discussed properties of modulus. So similarly, we will discuss properties of argument. Now, properties of conjugate and properties of modulus have some similarity between them. We have seen that. But what about properties of argument? So properties of argument has a very interesting thing. It has a similarity with properties of logarithm. Yes. Okay. So let us see. I will show you. Properties of argument में, suppose there are multiple complex numbers. Z1 is having what? Z1 complex number is what? Modulus e raised to power e theta 1. So this is the Euler's form of Z1. Euler's form of Z2 is what? This Euler's form of Z3, Euler's form of Zn. Okay, so one by one we will tackle all the properties, and you know that if I pick any complex number, the explanation of this is mod Z1 is what? Mod Z1 is the length from the origin, and theta 1 is the argument. Okay, theta 2, similarly theta 3 are arguments of multiple complex numbers. Now the very first property is argument of Z1 we know, right? Argument of Z1 is what? Theta 1. Argument of Z2 is what? Theta 2. But what about argument of Z1, Z2? Okay, argument of Z1, Z2. Okay, so argument of Z1, Z2, if I calculate, it is theta 1 plus theta 2. Let me show you. So let's calculate Z1 into Z2. Z1 into Z2, tell me. So ma'am, Z1 into Z2 is what? Mod Z1, mod Z2, e raised to power. Z1 is what? Iota theta 1, e raised to power iota theta 2. Correct? This is your Z1, this is your Z2. Just multiplied, simply multiplication. So Z1, Z2 mod I am not focusing on, I am just focusing on this, e raised to power. Now bases are same. Can we add the powers? Theta 1 plus theta 2, definitely. Right? Theta 1 plus theta 2, correct? Okay, now theta 1 plus theta 2, theta 1 plus theta 2, if I talk about this, okay, so this will be your mod of Z. Basically mod Z1, Z2 I can write, right? So this is your R, that is modulus, and theta 1 plus theta 2 will be your argument. So now, what is the similarity? Log AB is equals to log A plus log B, right? Now you must be wondering, ma'am, but hold on, what is this 2k pi? So basically this 2k pi we have added in order to understand that argument has a specific range. Remember, argument can only lie between minus pi to plus pi. Okay, so suppose the argument of Z1 is suppose 120 degree. Argument of Z2 is also 120 degree. Then the angle becomes what? Argument of Z1, Z2 becomes 240 degree. But 240 degree is not at all allowed. 240 degree is not fitting in the range of minus pi to pi. So because the angle has that cyclic nature, rather than writing 240 degree, can we have another angle which fits in our range? Okay, so for that adjustment, we need to convert 240 degree. So 240 degree is what? So it lies in third quadrant. Okay, so 240 degree. So third quadrant mein my range is 0 to minus pi. Okay, so a negative angle we will talk about. So minus 120 degree is the equivalent angle of 240 degree. So minus 120 degree is the right answer. Okay, so we'll solve, then you will let you know again. Argument Z1, Z2 is argument Z1 plus argument Z2 same. If I apply the same thing in general, if there are multiple complex number arguments Z1, Z2, Z3, Z4, Z up to Zn. So again, this is argument Z1 plus argument Z2 plus argument Z3, and the 2k pi is for the adjustment. Okay, all right, clear. Now, if all the complex numbers are equal, Z1, Z2, Z3, all the complex numbers are equal and is equals to Z, then what will happen? Then actually arguments basically Z, 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 right? Z, 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 everything becomes Z only, Z power N. So Z power N, argument of Z power N is what? Again, logarithm property, right? If we have log x raised to power N, so it is N log x. So argument of Z raised to power N is N times argument of Z. Again 2k pi is what? Adjustment angle. Okay. Again the negative sign. Argument of Z1 by Z2 will be what? Argument of Z1 minus argument of Z2. The logarithm property log A by B is log A minus log B. 2k pi is again for the adjustment. Now let us quickly do one thing. Let's just solve one problem so that we get the confidence. Okay, we are understanding what ma'am is trying to say. Argument Z1 is 160 degree, argument Z2 is 80 degree, argument Z1, Z2 is what? We need to figure out, okay? So, argument Z1, Z2 is argument Z1, formula I am applying, and yeah, argument Z2, sorry 160 degree क्यों लिखा, it will come in next step, right? Z1 argument Z2 plus 2k pi. This is for adjustment. Argument of Z1 Z2, tell me, 160 degree plus 80 degree plus 2k pi. 160 plus 80 is 240 degree. Okay. Now we need to add 2k pi because the position of the angle should remain same. Okay, so we clearly know 240 degree lies in third quadrant. Okay, so k can be -1. If you put k is equals to -1, na, it will become minus 2 pi. That is 240 minus 360. Okay, and just tell me, minus 120 degree, it lies between minus 180 to plus 180. This is the range of argument. So minus 120 is the argument of final argument. Okay, that's how you do it. Clear? Have a look and let me know. Okay, now let us talk about the next problem, which is again argument of z raised to power 50. We know that this is 50 argument z plus 2k pi. So 50 into argument z. Argument z will be what? Tan pi by 4. Clear? It is very clear. First quadrant mein. Okay, so tan pi by 4. So pi by 4 plus 2k pi. So this is 25 pi by 2 plus 2k pi. Obviously, k should be a negative quantity, right? So 25 pi by 2 is what? 12 point something. So basically, k can be equal to 6 minus 6. Let's take minus 6. Let's see what happens if k is minus 6. So minus 12 pi plus 25 pi by 2. So minus 24 plus 25. So pi by 2 is the right answer, and pi by 2 is in my range. So pi by 2 is the correct answer of this particular question. Okay. All right. Let us now talk about the next question. Consider 2 points on of a non-zero conjugate complex number z1 and z2. 2 points of non-zero conjugate complex numbers z1, z2 and z3, z4. Find the value of argument of z1 by z3 plus argument of z2 by z4. So basically, we need to understand that. Okay. So we are looking for argument of z1 by z3 plus argument of z2 by z4. Okay. All right. Now let us apply that property. Argument of z1, z2 is argument z1 plus argument z2. So reverse property. So this is going to be argument of z1, z2 upon z3, z4. This is what we are looking for. Okay. All right. Okay. Now the very first statement is a slightly confusing statement. Okay. Consider 2 points of non-zero conjugate complex numbers. What does that mean? This is point number 1. This is point number 2. Okay. So point number 1 is having two things, z1, z2. So basically, these two are conjugate of each other. Z1 and Z2 are conjugate of each other. Z3 and Z4 will be conjugate of each other, right? So I can just simply write Z1 is Z2 bar and Z3 is equals to Z4 bar. Okay. So Z1 is Z2 bar. So here I can write Z2 bar Z2 upon Z3. Z3 is as it, so Z3 can be written down as Z4 bar Z4. Okay. Now Do you remember the hero property of complex number? Z bar is mod z square. So this is argument of mod of z2 square upon mod of z4 square. Understand what is happening. This is a real quantity. Argument of a positive real quantity. This is a positive real quantity. This is again modulus of some quantity, modulus of some quantity, and square of modulus. So argument of a positive real number. Tell me, argument of any positive real number is a big fat small cutie pie, 0. Okay, so 0 is the correct answer of this particular question. Okay, all right, similar line, on similar line we have another question. Zk is given as cos pi by 2 power k plus iota sin pi by 2 power k. Then find the value of product of z1, z2, z3 and all the way up to infinity. Okay, so let's do one thing. Zk, can I write zk as e raised to power iota pi by 2 raised to power k? Can I write it this way, Euler's form? So now just tell me, what is z1? So ma'am, z1 is e raised to power iota pi by 2. What is z2? Ma'am, e raised to power iota pi by 2 square. Z3, e raised to power iota pi by 3, sorry, pi by 2 cube. Z4, e raised to power iota pi by 2 power 4. Right? We need to take product. Z1, Z2, Z3, Z4 and all the way up to infinity is equals to what? E raised to power iota pi by 2, e raised to power iota pi by 2 square, e raised to power iota pi by 2 cube and all the way up to infinity. Now, bases are same. We can add the powers. E raised to power iota can be taken common. Pi by 2 plus pi by 2 square plus pi by 2 cube. Basically an infinite GP is getting created. E raised to power iota pi by 2 also you can take common. 1 by 2. Okay, so 1 plus, not 1 by 2. 1 plus 1 by 2 plus 1 by 2 square all the way up to infinity. Nth infinity of a GP will be a upon 1 minus r. So 1 plus 1 by 2 and all the way up to infinity will be equal to a upon 1 minus r. So 1 upon half, 2. Okay, so e raised to power iota pi by 2 multiply 2. So this is e raised to power iota pi. E raised to power iota pi. Do I need to tell you? This is again the most beautiful equation. Minus 1 is the final answer. So final answer of this question is clear cut minus 1. A very good, beautiful question, I will say. And note it down. Note it down. Okay. Before we start with the next question. All right. Okay. Chalo. Ready? Next question ready? Yes, yes, yes. All right. If z and omega are the complex numbers satisfying mod z plus iota omega bar is 0. This is what they are saying. Argument z omega is pi, then argument z is equals to. Okay. All right. Let's do one thing. Argument z omega is pi. So I can break this down now. Argument z plus argument omega is your pi. Perfect. What about this? Z bar is equals to minus iota omega bar. Okay. So let's do one thing. Let's take conjugate both the sides. So Z bar is equals to minus iota omega bar whole bar. So this is Z only. This is going to become minus iota bar omega bar whole bar. Z is equals to, this is simply iota. We just need to change the sign of the constant which is there with iota. So this will become plus iota. This is omega only. So Z is equals to iota omega. Correct? Z is equals to iota. Now take argument on both the sides. Argument Z is equals to argument of iota omega. Argument iota plus argument omega. Argument of iota, we know that pi by 2, purely imaginary positive number. Pi by 2 plus argument omega. This is your argument z. What are we looking for? Argument z. So argument omega, from here we can calculate arg z minus pi by 2. We can put this value of argument omega over here. So we will get arg z plus argument omega is again arg z minus pi by 2 is equals to pi. So this is 3 pi by 2 is equals to twice of argument z. Argument z is coming out as 3 pi by 4. So we just need to use the basic properties of argument. So in here, this property to everyone will use. But there are a very few people who will think that, okay, let's first convert this z bar into just purely z by taking conjugate on both the sides. And once we get the equation, just take argument on both the sides and apply the properties of argument. Very few people will be able to think originally for the very first time. But now that I have told you, okay, this is how it is done. So next time, whenever you see this question, you will be like, take argument both the sides. Yes or no? Write in the chat box. Yes or no? Okay. So, okay, answer will be 3 pi by 4. 3 pi by 4 will be absolutely right. Now let us talk about the next problem which was asked in JEE Main 2020. Okay, the value of this is equal to what? Is what they are looking for. Okay, all right. So, there is a very interesting trick to solve this problem. Let me tell you that trick. Okay, so clearly sine 2 pi by 9 plus iota cos 2 pi by 9 is what written over here, which is the wrong format. What is the correct format? So many of you will tell me this is the right format. No, the correct format is cis theta cos theta plus iota sin theta is the correct format. Okay, all right. Anyway, but we are here to handle such things. First thing which I can understand is sine 2 pi by 9 plus iota cos 2 pi by 9 is written. Okay, so see, this is your z. Let us consider z as sine 2 pi by 9 plus iota cos 2 pi by 9. Just tell me, mod z is what? First of all, mod z is 1. And z bar is also given. This, the denominator mein there is a z bar. Sine 2 pi by 9 plus iota, sorry, minus iota cos 2 pi by 9. This is your z bar. Okay. Now, hero property will come into the picture because z is already there, z bar is already there, mod z is 1. Z bar is equals to mod z square, and this is 1 in this case. So, z bar is 1. This is the property which we are going to use in this question. Let us rewrite this question in the form of z. 1 plus z upon 1 minus z bar whole cube. 1 plus z upon 1 minus z bar whole cube. You will understand that what I am trying to say. So 1 plus z is as it is. 1 minus z bar. Z bar is 1 by z. Z bar is 1 by z. Whole cube is as it is. Okay. All right. This is minus, right? No, sorry, it is plus only. Plus, plus, plus. Yes. Now take LCM. So this is z plus 1. Z plus 1, z cube. Clearly, if you take LCM, z plus 1 is gone. This is nothing but simply z cube. Simply z cube. What are you looking for is, okay. So z cube, that means it is sine 2 pi by 9 plus iota cos 2 pi by 9 whole cube. Now sine 2 pi by 9 plus sine plus, can I just, when I told you, whenever there is power of z, always think about Euler's form. But this is actually written down in polar form. We just need to convert in Euler's form. But there is a big challenge because there is a disturbance in this trigonometric form or polar form. Sine plus iota cos. No, I don't want that. I want cos plus iota sine. For that, I need to convert this into cos and this into sine. Let's do that. Sine 2 pi by 9 is equals to what? Cos of 90 minus pi by 2 minus 2 pi by 9. Can I write this way? Cos 90 minus theta is sine theta. Okay. So cos of 9 2s are 18. 9 minus 4, 5. 5 pi by 18. Similarly, cos 2 pi by 9 is equals to sine pi by 2 minus 2 pi by 9. So this is sine 5 pi by 18. Correct? So this is actually becoming cos 5 pi by 18 plus iota sine 5 pi by 18. Okay? Complementary angles cube. And this is going to become e raised to power iota theta 5 pi by 18 power 3. Let's not forget. Now these two will get multiplied. 3 ones are 3 6 are. So e raised to power iota 5 pi by 6 is the final answer. E raised to power iota 5 pi by 6. Now e raised to power iota 5 pi by 6. Again, if I convert into polar form, cos 5 pi by 6 plus iota sine 5 pi by 6. Okay, so cos 5 pi by 6, cos pi minus pi by 6, minus cos pi by 6, minus root 3 by 2, plus iota, this is 1 by 2, minus root 3 by 2, minus root 3 by 2. Option C, minus root 3 by 2, minus minus plus iota by 2 is absolutely right. Okay. Perfect. All right, clear. Now we are having one more question in our plate, on our plate, which is find the real part of z is equals to e raised to power iota theta. Okay. All right. So e raised to power iota theta. How do we tackle it? So first of all, this e raised to power iota theta can be written down as e raised to power cos theta plus iota sine theta. And now what I can do is I can just break, right? A raised to power x plus y is what? A raised to power x, a raised to power y. Let's make use of it and break it. E raised to power cos theta, e raised to power iota sine theta. Now understand, e raised to power cos theta is purely real part. This is purely real. Now e raised to power iota sine theta has both real and imaginary. Okay. So again, let's expand this. So e raised to power cos theta, there is no need to expand. This is because this is a purely real number. E raised to power iota whatever, e raised to power iota theta or e raised to power iota alpha is what? Cos alpha plus iota sine alpha. Correct? Okay. Now multiply. Or you can say this is your real part, this is your imaginary part. Real part will get multiplied with real part, so e raised to power cos theta. Cos of sine theta is your real part. And imaginary part will be this product, this. So find the real part, e raised to power cos theta, cos of sine theta is your real part. Okay, clear? Any doubts, any confusion? Do write in the chat box. Okay. All right. So now we will talk about de Moivre's theorem. Okay. So what does this de Moivre's theorem do? De Moivre's theorem enables us to calculate the solution of the equation of some type that we are going to understand. Okay. So, yes. So de Moivre's theorem says that if n is z, that is an integer, then cos theta plus iota sine theta raised to power n can be written down as cos n theta plus iota sine n theta. Let's understand. Let's understand. Yes. So here cos theta plus iota sine theta can be written down as e raised to power iota theta. Perfect. Any issues in this? Now what I'm going to do is, I am going to take power n on both the sides. Okay, where n is an integer right here. Perfect. Now these two, e raised to power iota theta and n, will get multiplied. So e raised to power iota n theta. Right? So now e raised to power iota theta. You know the formula, right? E raised to power iota theta is what? Cos theta plus iota sin theta. So basically, if I replace this theta by n theta, what will I get? E raised to power iota n theta is equals to cos n theta plus iota sin n theta. Okay. So that means this will be equals to e raised to power iota n theta will be equals to what? Cos n theta plus iota sin n theta. Basically, this power n, with the help of Euler's identity, we can take this n inside of this theta. So n will get multiplied with theta. So whenever you see cos theta plus iota sin theta cube, so it is nothing but cos 3 theta plus iota sin 3 theta. Okay. So this is applicable only when the n is integer. But what about when n is a rational number? Okay. When n is a rational number, then cos theta plus iota sin raised to power theta power n will be equal to cos theta plus cos n theta plus iota sin n theta. So these two will be equal, but it will be one value. There will be more values. Let me tell you. Do not worry about it. So integers wala to it's clear, but if n is a rational number, then it will have multiple values. One such value of the multiple values of this expression will be this. Just keep that in mind. We will understand it step by step. Okay. All right. Clear. Now let us do one thing. Let us just do one question. Okay. Z raised to power 4 is equals to 1. Let us do one question to understand that how we can actually apply the de Moivre's theorem to calculate the solution of these type of equations. Okay. Z raised to power 4 is equals to 4. So Z will be equals to 1 raised to power 1 by 4. All right. Understand, this 1 is a complex number which can be written down is in the form of cos theta plus iota sin theta. So cos 0 degree or cos 0 pi plus iota sin 0 pi. I can write it this way. Cos 0 plus iota sin 0 power 1 by 4 is already there. Z will be equals to cos 0. So e raised to power iota 0 also you can write. Okay. 0 is the argument. But do you remember that we were adjusting the argument? See, Z raised to power 4 is equals to 1. It will have obviously 4 solutions. Right? Obviously 4 solutions. How? Why 4, ma'am? Because we are like not imposing a restriction that calculate only real solution. 4 solutions including mixed, real, imaginary, whatever, but 4 power, so 4 solution will be there. Right? So 4 solutions we have to calculate. Okay, now what I'm going to do is 0 is the argument, right? But argument can be written down like this. Do you agree? E raised to power iota 0 plus this 0. This is plus 2k pi. Can I write down in this manner? And this is having power 1 by 4. Right? So always, this is a step-by-step technique that whenever you have to figure out the solution of these type of equations, convert this into either trigonometric or polar form. Both are like very, very similar forms. Right? Once you are done with that, and now what you need to do is, before this 1 by 4, let's keep it aside. Just add 2k pi in your argument, and then now the last step is apply de Moivre's theorem, which says this 1 by 4 will be multiplied with this 2k pi by 4. So this is Z is equals to e raised to power iota k pi by 2. K pi by 2. And now you are here to calculate the solutions. Now the method says that you need 4 solutions. Start with k is equals to 0, 1, 2 and 3. That's it. Because you need 4 solutions. Stop it at 3. K is equals to 0. You will get Z is equals to e raised to power 0. E raised to power iota 0 pi by 2. So this is going to become 1. Z1. Z2 you will get the moment you put k is equals to 1. So e raised to power iota pi by 2. If you solve it, cos pi by 2 0, iota sin pi by 2. So this is your iota. Z3, you put k is equals to 2. So the moment you put k is equals to 2, 2 by 2 e raised to power iota pi. Now this is your minus 1. And last Z4, you put k is equals to 3, 3 pi by 2 e raised to power iota 3 pi by 2 will be minus iota. So 1 iota minus 1 minus iota will be the answers. And obviously z raised to power, if you solve it with alternate method also, na, z raised to power 4 is equals to 1. Okay, so z square will be what? Tell me. Plus minus 1. So z square is equals to 1 will give you z is equals to plus minus 1. Right? First thing. Second thing, z square being minus 1. So that means z is equals to plus minus iota. Right? But I have taken a simple example to tell you that how things are done. Okay. Now let us take one more example. A difficult example, a little bit tricky example, z raised to power 4 minus 1 plus iota, right? So these de Moivre's theorem, na, everybody feels that this is tough. No, just understand the steps, you will be fine. So 1 plus iota raised to power 1 by 4. Now convert this internal thing into Euler's form. Okay, so this is, okay, 1 plus iota, let us just do that. R cis theta or R e raised to power iota theta, R is root 2. E raised to power iota pi by 4. Okay, now just replace. Root 2 e raised to power iota pi by 4. Power 1 by 4. Correct? Now this constant, this modulus thing, you can keep it aside. Root 2 power 1 by 4 will be 2 raised to power 1 by 8. And now e raised to power, please do not do that. Do not hurry. 4 4s are 16, e raised to power iota pi by 16. No, it is not going to work like that. Now, in the argument itself, add 2k pi, step by step, 2k pi, okay, in the argument, pi by 4 plus 2k pi is already there, and now we have 1 by 4 as the power. So now this will be 2 raised to power 1 by 8, and this is going to become e raised to power. Now 1 by 4, now you multiply 1 by 4, so e raised to power iota pi by 16 plus 2k pi by 4, so k pi by 2. Now, this is your z. Now you know what to do. How many solutions? 4 solutions. So k is equals to 0. K is equals to 0, 1, 2, 3. That's it. First, k is equals to 0. So z will be 2 raised to power 1 by 8. E raised to power iota pi by 16. One solution. Z1. Z2 will be 2 raised to power 1 by 8. E raised to power iota pi by 16. So k is 1. Pi by 2 plus pi by 16. So, 9 pi by 16. Now, k is equals to 1, right? Now, k is equals to 2. Pi plus pi by 16. 17 pi by 16. Z3, you put k is equals to 3. Right? K is equals to, sorry, Z4. K is equals to 3. So 3 and 3 is a 24. 24 plus 1, 25. Correct. E raised to power iota 25 pi by 16. These are the values. Okay. All right. Have a look and let me know whether you are understanding de Moivre's or not. All right. Now let us talk about cube roots of unity in a similar manner, right? Let Z be a cube root of unity. Cube root of unity is very popular topic if you know, right? Yes. So again, Z cube is equals to 1. Z is equals to 1 raised to power 1 by 3. Cube root of unity. Cube root of unity means 1. So that's why the topic is cube root of unity. First of all, understand what is the meaning of cube root of unity. So now again we are going to apply the same process 1 can be written down as, understand, 1 can be written down as e raised to power iota 0 in Euler's form, right? Because 1 is what? Cos 0 plus iota sine 0. So e raised to power iota 0. Now what will you do? Z will be equals to e raised to power iota 0 plus 2k pi. Add 2k pi in the argument, power 1 by 3. Z will be equals to, now divide by 3. E raised to power iota 2k pi by 3. And now k will be varying from 0, 1, 2. Because you need only three solutions of this equation. No, only 0, 1, 2. K is equals to 3 will not work for you. Only 0, 1, 2. You put k is equals to 0, you will get your Z1. First root of this equation. K is equals to 0. The moment you put k is equals to 0, e raised to power 0. So Z1 is 1. Z2. The moment you put k is equals to 1, e raised to power iota 2 pi by 3. Z3. E raised to power iota 2 to the 4 pi by 3. Okay, e raised to power iota 4 pi by 3. So Z1, Z2 and Z3. Okay, clear? Okay, so these are the, now e raised to power iota 2 pi by 3, you know, right? You can calculate. This is cos 2 pi by 3 plus iota sine 2 pi by 3. Cos 4 pi by 3 plus iota sine 4 pi by 3, right? So if you like solve it, this will be cos 2 pi by 3. So minus 1 by 2 plus iota root 3 by 2. This is minus 1 by 2 minus iota root 3 by 2. Okay. So z cube is equals to 1 will have 3 roots. First root is 1. Second root is this. Third root is this. Now there is an alternate method also. Alternate method is again the algebraic method. Z cube is equals to 1. Now factorize. A cube minus B cube is what? A cube minus B cube is A minus B. A square plus AB plus B square. So from here, one root is Z is equals to 1. It is very clear. Now if you solve this quadratic equation with the help of the formula method, you will get 2 roots. And those 2 roots, if you solve it, you will get, okay. So those 2 roots will be minus 1 plus minus square root of B square minus 4AC says. So you're going to get what? E raised to power iota 2 pi by 3, e raised to power iota 4 pi by 3. These are those 2 roots, okay. And if you carefully observe, so basically roots of this equation will be 1 omega omega square. This is the standard notation of cube roots of unity. First root is 1. Second root is omega. So 1 out of these 2 is omega. Then other is omega square. Okay. Alright. So properties of cube roots of unity. Let's understand this is 1 omega omega square. Okay. So if you square it now, you will get this only. You will understand. If you square it, you will get this only. So cube roots of unity. Now sum of these 3 quantities. Obviously sum of roots. Theory of equation, sum of roots is minus b by a. That means minus of coefficient of z square by 1. Coefficient of z square is missing. Sum of roots in this equation is 0, right? And if you add these 3 also, right? Omega is this, omega square, you know that, okay? So omega square. This is so there. But properties mein, sum of the cube roots of unity is 0. So if you add 1 omega and omega square, 1 omega and omega square. So 1, then this square. 1 plus omega and omega square. If you add this, you will get a 0, a clear cut 0. Okay. So sum of cube roots of unity will become what? 0. You add them, you will get 0. And by theory of equations also, it is suggesting that sum of roots of this equation is 0. So what does that mean? So 1 plus omega square becomes what? 0. Okay. Next property is omega cube. Omega cube, that is product of cube root of unity. Product means what? First root is omega, first root is 1. Second root is omega. Third root is omega cube. Alpha, beta, gamma. Product of roots will also become, if this is the equation, see, if this is the equation, product of roots will be what? Minus of d by a. So minus 1 by 1. So this is going to become 1 only. Product of roots will be 1 omega square. If you multiply omega cube will be 1 because theory of equations also. Or if you multiply 1 and this multiply this, if you multiply these two, then also you will get 1. So product of cube root of unity is 1. So these two things are very, very important. 1 plus omega square and omega cube is equals to 1. This is 0 and this is 1. Okay. All right. Clear. So omega cube is 1. Then we can derive multiple things. Okay. Also one more thing. Understand z cube is equals to 1. It has 3 roots. Can we just do one thing? Can we just plot all the 3 complex numbers in the Argand plane? 1, omega square. Let's do that. 1 is a complex number, 1, 0. Plotting of 1, 0 is very easy. Then omega is what? E raised to power iota 2 pi by 3. 120 degree. 120 degree is the angle and 4 pi by 3. So 240 degree, this is the angle. So if you see, these 3 are the lines. This is having 0 degree angle with the real axis, having 2 pi by 3 angle with the real axis, having 4 pi by 3 as the angle with the real axis. And if you join these 3 points, you will realize that this is forming an equilateral triangle. This is forming an equilateral triangle, and distance of the center from this and this is 1. So it is actually what? Representing radius of this circle, whose radius is 1, obviously, because this length of this is 1, right? Radius is 1 and the angle is, this is 120 degree. Angle between these 3 radiuses are 120 degree, okay? So if we represent cube roots of unity by points in Argand plane, they form an equilateral triangle. Now, the side of this equilateral triangle will be root 3. Okay, and also they lie on a circle with unit radius. Okay, let us do one thing. Let's do one question on cube roots of unity. Okay, all right. Let's do it. Evaluate r is equals to 0 to 100, 1 plus omega power r plus omega power 2r, where omega is an imaginary cube root of unity. Okay, r is equals to 0, so 1 plus 1. R equals to 0. We have let's do one thing. Okay, so 0 to 100, sigma 1 plus sigma omega power r plus sigma omega power 2r, correct? R equals to 0 to 100. How many numbers are there between 0 to 100? 101. So 101 plus r is equals to 0 to 1. So 1 plus omega square plus omega cube plus omega power 4 and all the way up to omega power 100. Okay, 1 plus omega square is becoming 0. Omega cube is becoming 1. Then omega power 4, omega power 5 plus omega power 6. Understand? Omega power 4 is what? Omega power 4 is omega cube dot omega. Omega power 4 is omega only. See what is happening. 101 plus 1 plus omega square plus omega cube plus omega power 4 is omega cube separated out. That is 1. So single omega power 5. So omega power 5 is equals to omega cube omega square. This is 1. So only omega square plus omega cube. So this is omega cube. So this is omega cube is 1. This is your 1. Omega plus omega square plus 1. Okay. All right. Next. 6. So omega power 7 is omega plus omega power 8 is omega square plus omega power 9 is 1. Right? So can you see these things are becoming 0. This is gone, this is gone, this is gone. Okay. All right. So omega cube only this is pending 101 plus this is omega cube 1 is pending. Now last May there will be omega power 97 plus omega power 98 plus omega power 99, right? So again, see this same thing. This is omega square 1. This is also gone. Last में there will be omega power 100, that will be pending. Omega power 100 will be omega power 99, which is 1. And then only 1 will be left out. So this is 101 plus this is 1. Omega power 100 will be omega. Plus now this thing, omega power 2r. So r is equals to 0 again. 1 plus omega square plus omega power 4 plus omega power 6 and all the way up to omega power 200. Okay, again same thing is getting formed. Omega power 4 is omega. So 1 is left out. This is omega square, omega and 1 gone. Right? Okay. So how many terms are there? Understand. So over here there are 101 terms. Okay. 101 terms. So 99 terms will be gone. Only 2 terms will be left out. The first term and omega power 200. Again, this is omega square. So this will be 1 plus omega square. So 1 plus omega square. So 101, 102, 103 plus omega square. Now you know that 1 plus omega square is equals to 0. Omega plus omega square is minus 1. So 103 minus 1, 102 is the final answer of this question. Okay, have a look, let me know. Okay, now the last question on cube root of unity we will do. Then we will do a new topic. So z plus 1 by z is equals to 1, then z raised to power 100 plus 1 upon z raised to power 100. Okay, so again z square plus 1 is equals to z. So z square minus z plus 1 equals to 0. If you solve it, z will be equals to 1 plus minus root 3 iota by 2. Okay, all right, understand what is happening. See, z square minus z plus 1 equals to 0 will have roots omega and omega square. We just saw, right? This is one of the factors of z cube minus 1. This was we were getting. If you solve it, omega and omega square are roots of this quadratic. Okay, and omega will be minus 1 plus minus root 3 iota by 2. Right, omega and omega square. Now understand, if you multiply minus sign in this will become plus. And this plus minus will remain plus minus only, right? Minus plus, but yeah, you're going to get the same thing. So yes, can you compare what is the difference between these two? Only the difference is if you multiply negative sign in this roots, you will get this. That means roots of this equation will be, hold on, this is plus, sorry, plus wale mein minus 1. So z square plus z plus 1 has 2 roots omega square. Z square minus z plus 1 will have 2 roots minus omega and minus omega square. Keep that in mind. That will help us in solving the problems like this which have higher things. Okay, so that means this z is either minus omega or minus omega square. Okay, so we need to calculate the value of this. So case number 1, when your z is minus omega, and put minus omega power 100 plus 1 upon minus omega power 100. Omega power 100 plus 1 upon omega power 100, correct? Omega power 99 into 1. Omega power 99 is 1. So this is actually omega plus 1 upon omega. So here omega LCM, omega square plus 1. And this is coming out as minus omega as upon omega. Minus 1 is the correct answer. So minus 1 in first case. And if you take z is equals to minus omega square also, no? Case number 2. Z, in case it is minus omega square, then also you will get the same result. No controversial, no contradictory result. Okay. So this is going to be minus omega square power 100 plus 1 upon minus omega square power 100. Omega power 200. So omega power 198 into omega square. 190 is its multiple of 3. So this is omega square only. plus 1 upon omega square. Correct? If you take LCM, omega square is down. This is omega power 4 plus 1. Omega power 4 is again omega cube into omega. So this is omega plus 1. Omega plus 1 is minus omega square upon omega square. Omega square cancelled. Minus 1 again. Minus 1 is getting the answer. Okay. All right. Clear. Have a look. All right. So now we will deal with geometrical interpretation of modulus. Okay, so you have seen till now we have covered so many things. We have covered algebraic form of complex number. We have covered basically polar form of complex number, Euler's form of complex numbers. Then we have seen cube root of unity, basically the de Moivre's theorem, and after that we are going to talk about the geometrical interpretation of different things. Okay, especially the modulus thing. And trust me, this particular segment will convert your difficult problem into your basic geometry class 10 problem. Yes. So, understand that what is happening. Mod Z1. So, this I have already told you, by the way, that what is mod Z1? Mod Z1 is obviously modulus of that complex number. That means distance from the origin, right? Yes, so distance from Z1 from the origin is represented by mod Z1, and if I talk about mod Z2 minus mod Z2 minus Z1, so in here this is actually representing distance between Z1 and Z2. Please keep that in mind. Let's do the very first question based on this. Okay, so first question says this is 2. Change the data, this is 2. Yeah, Z1, Z2 and Z3 be 3 complex numbers such that mod Z1 plus 2 is less than or equal to 1. What does that mean? Tell me. This, if I just write down in the standard form, this is mod of Z1 minus 2 mod close less than or equals to 1. So, see, mod Z1 minus Z2 is distance between Z1 and Z2, right? So, here distance between Z1 and minus 2 is less than or equal to 1. Minus 2 complex number. Complex number minus 2 is absolutely fixed. Okay. Now distance between Z1 is a variable point. It is not fixed. Okay. We need to figure out the maximum value of mod Z1, mod Z2, mod Z3. So that means Z1 is a variable thing. We need to make sure that Z1 value is such that that its modulus is Z1, right? Modulus is maximum, right? So now mod Z1 minus 2. Distance between Z1 and minus 2 is 1 or less than that. So that means it is forming a circle. Z1 is always lying on a circle whose center is minus 2, 0 and radius is 1. Either lying on it or inside it. So Z1 has, what all points can be Z1? Tell me. So Z1 can be here, Z1 can be here, Z1 can be here, Z1 can be inside the circle as well, right? But I want my Z1 to be maximum distance from the origin. So for that, Z1 value should be this, and this point clearly, if this is your 1, right? So this is your 1. So this point clearly, this is not intersecting with hold on. Circle has a radius. Yeah. So this is your radius 1. So minus 3, 0 is the maximum possible distance from the origin. So mod Z1 is coming out as 3. Correct? Similarly, mod Z2, if you focus, mod Z2 is actually, so if you focus on this again, minus 2, 0 is the center, but 2 is the radius. This time, this is the circle. So this is minus 2, 0. Again, Z2 lies on the circle or inside it. So this is your minus 4, 0. So this is your Z2 point. This is your Z1 point. And this is mod Z3 plus 4 less than or equals to 4. So basically, the radius is also 4 and the center is minus 4. 1, 2, 3, 4. So radius is 4, center is minus 4. So minus 8 is your Z3, correct? So 8 then 4 and 3, right? So mod Z1 will be what? 3, mod Z2 will be what? 4, and this is 8, 8 plus 4, 12, 12 plus 3, 15. 15 is the correct answer of this particular question, okay? There is some mistake in this question, so 15 will be the absolutely correct answer, okay? 15. So final answer is 15. You can just ignore the options, right? 15 option is correct. So in this question, we have understood what does mod Z1 plus Z2 or mod Z1 minus Z2 equals to some constant or less than or equal to some constant or greater than or equals to some constant mean. Okay. All right. All right. Now let us move on to the next problem. Yes. Next problem says that Z1, Z2, Z3 are vertices of an equilateral triangle ABC such that mod Z1 minus iota is equals to mod Z2 minus iota is equals to mod Z3 minus iota. So basically what we are saying is iota is the second complex number. 3 points are there, Z1, Z2, Z3, and this is forming an equilateral triangle ABC such that distance from iota, where is iota? Tell me. Iota is here. Distance from iota is 0, 1. Distance from iota of this particular point, these particular points, these particular vertices are equal, right? So that means clearly this is the circumcenter, right? So if I just draw this triangle now, then this will work. See, if this is a triangle, equilateral triangle, understand. Distance from this iota from Z1, Z2 and Z3 all are equal, right? So this is circumcenter, but in case of equilateral triangle, you know, circumcenter and centroid coincide with each other, right? So basically, centroid of this is iota, so Z1 plus Z2 plus Z3 by 3 is iota, centroid formula. So Z1 plus Z2 plus Z3 is 3 iota. If you take modulus on both the sides, it is going to become 3. In this case, option C, 3 is absolutely right. Okay. Clear? Chalo. Now let's talk about the next. So 3 is absolutely right. Let's talk about the next problem. Next problem is all about, okay, very good problem. Okay. The area of triangle whose vertices are represented by complex number 0, z e raised to power iota alpha is equal to, okay. Understand, first is origin 0, 0. First vertex is origin. Second is z. Now z, you know that z is r cis theta or r e raised to power iota theta. This is your z, right? So second vertex has coordinate z, or it can be r cos theta comma r sin theta, correct? Right? The third point will be z e raised to power iota alpha. Understand, z is what? Z is e raised to power iota theta into r. This is your z. Z into e raised to power iota alpha. This is your z e raised to power iota alpha, third vertex. So this is r e raised to power iota theta plus alpha. This is equals to sine theta plus alpha. Sorry, cos. R cis theta, right? So this is going to become r cos theta plus alpha plus iota sine theta plus alpha, right? What is the x coordinate? Tell me. X coordinate is r cos theta plus alpha, y is r sine theta plus alpha. So this is r cos theta plus alpha, comma r sine theta plus alpha. So this is your A, this is your B, this is your C. Now you have got all three coordinates. What you need to do is you just need to apply that area of triangle formula, which is half x1 y1 1. So first coordinate is origin 0 0 1, x2 y2 1, second row. So r cos theta, r sin theta 1. Third coordinate r cos theta plus alpha, r sin theta plus alpha 1. Close this is what we need to calculate. Half is already there. Okay. So just 1 and this r cos theta, r sin theta plus alpha. R square cos theta sin theta plus alpha minus this cross this r square sin theta cos theta plus alpha mod close. Okay. So this is going to become half. R square is common. Sin A cos B minus cos A sin B is sin A minus B. This is sin A. This is B. Sin A minus B. So sin alpha, right? R is what? R is mod Z, right? Half mod Z square sin alpha is your absolutely right answer, which is matching with option B. Okay. All right. Clear? Let me know that if it is clear to you or not. Chalo. Let us now move on to the next problem, and in this problem more geometry, yes, a little bit more geometry will be involved. Understand? Okay. Let Z be a complex number satisfying mod of Z minus 5 iota less than or equal to 1. Okay. So in here you need to plot this. So what they are saying is 5 iota, distance between Z and 5 iota is 1 or less. Okay. So 5 iota is fixed. So 0, 1, 2, 3, 4, 5. This is your 5 iota. Okay. Right? 5 iota. Now, Z is such a number whose distance from this point is always fixed, which is 1. That means circle. Z is nothing but lying on a unit circle whose center is 0, 5. This is your circle. Correct? All right. Now, this Z lies where? Understand. Z lies where? On the circle or inside the circle. Correct? Okay, ma'am. Correct. Such that amplitude of Z is minimum. Okay. So now Z can be anything. Z can be this point. Z can be this point, 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 and Z can be any point inside this. Right? Now I want amplitude of my Z to be minimum. Okay. Amplitude of Z should be minimum. So understand one thing, that amplitude, okay, it starts with 0 degree. All right. And it goes, so this is pi by 2 angle. So suppose your complex number lie on the x-axis, real axis. So amplitude will be 0. Suppose your complex number lie in first quadrant, amplitude will be positive, right? And then if it goes over here, and then if it is lies in the second quadrant, then amplitude will be much greater, right? So clearly, as per the diagram, the amplitude can never be this, right? So Z cannot be this. So Z cannot lie in the second quadrant. That's what I'm trying to say. If Z lies in the second quadrant, then what will happen? The angle will be greater than 90 degree, which we do not want. We want my amplitude to be as minimum as possible. And in here, we know that to get a minimum value, my Z complex number should be as minimum as possible. So my agenda is to make the complex number here, right? That's the minimum complex number. That's the minimum amplitude. Because if my Z is not here, and if it is anywhere, if it is here, suppose it is here, then the amplitude will be bigger. If it is even here, then also the amplitude will be bigger. Are you getting my point? That's the only point, white color line is the only point where my amplitude is minimum, and this is nothing but the tangent. Okay. So I'm just increasing my amplitude from 0 degree, and my Z should either lie on this circle or inside the circle. So the moment my line touches the circle, that is when I will get the minimum amplitude. Okay, minimum amplitude. Perfect. Okay. So I just need to know this particular point. Understand. Now this is your 5. This whole length is your 5. This is O. Let us mark this as A. We are looking for coordinates of A. So this length is 5. Radius of this circle is 1. This is perpendicular. If you apply Pythagoras theorem in this will become root 24. Suppose if I take this as theta, okay, and if I complete the circle over here, I just draw the line like this. Yes. So this is your theta, correct? And hold on. So this. This length is root 24. Hold on, I will make this one more time. This length is root 24. This is your perpendicular. This is, I am marking it as theta. This angle I am marking it as theta. This is root 24, correct? Okay. So just tell me, if this hypotenuse is root 24, this will be root 24 cos theta and this will be root 24 sin theta. Perfect. So obviously coordinates of A will be what? Tell me. Root 24 cos theta, root 24 sin theta. Now I just want to know the value of cos and sin theta. Perfect. Theta is here. This will be 90 minus theta and this will again be theta. So from here, can you calculate cos theta? Cos theta from this triangle. So perpendicular by hypotenuse 1 by 5 and sin theta will be, cos theta will be, sorry. So this is theta base upon hypotenuse. So 1 upon 5 is cos theta. Sin theta will be perpendicular by hypotenuse. So that is root 24 by 5. Just plug in the value. So root 24 by 5 comma root 24 into root 24 by 5 is your coordinates. So root 24 by 5. So obviously theta is not correct. Root 24 by 5. Root 24 is what? 2 root 6 by 5. Option A. And this is 24 by 5. So option A is absolutely right. This is your plus sign. Option A is absolutely right. In here option C is wrong. Option A is correct. Okay. There is some mistake in this marking of the solution. Have a look. Let me know whether you are satisfied with the solution or not. Okay. All right. Perfect. Now let us do one last thing, which is triangle inequalities. Let us quickly go towards the triangle inequalities, right? So triangle inequalities basically are used to calculate the maximum or minimum value of modulus of complex numbers. Okay. So there are two triangle inequalities. Again, triangle inequality is what? Sum of two sides is greater than or equals to third side. Difference of two sides is greater than or equals to difference of two sides, right? Like that. So sum of two sides is greater than or equals to third side, basically. Sum of two sides individually, right? So first is mod of z1 plus z2 is less than or equals to mod z1 plus mod z2. Okay. Second is mod of z1 minus z2. Whenever you see negative sign over here, na, sign is greater than or equals to mod z1 minus mod z2. Understand that whole modulus will be applicable, because if a minus b is there, something minus something, there are chances that this will be smaller and this will be bigger. But I want everything to be positive, because you know modulus deals with only positive number. That's why one more modulus is there. Now, how to apply triangle inequalities is the major concern of many students. Okay. So understand, find the maximum value of mod z plus 2 if maximum and minimum both, if mod z plus 1 is equals to 4. First of all, just write your triangle inequalities. Mod of z1 plus z2 less than equals to mod z1 plus mod z2. First, okay. And second will be mod of z1 minus z2 will be greater than or equals to mod of z1 minus mod of z2. Just remember, just write down. Okay, do not get scared, because I know so many of you are scared of triangle inequalities. Do not get scared. You will be like, once you remember this and once you just have to put the values now. Okay, so the confusion arises exactly how to put the values, where exactly I should take. Okay, so yes, maximum and minimum. So here, can you see mod of z plus 1 is given to you and you're looking for mod of z plus 2, right? So I need to create this expression with the help of this. It's very easy. Mod of z plus 2 with the help of mod of z plus 1 creation is very easy. It will be mod of z plus 1 plus 1. As simple as that. This is your z1. This is your z2. Less than or equals to what is your z1? Ma'am, mod z1 plus, and this is your plus 1. That's it. Now this is mod z plus 2, that this minimum and maximum value of this you're looking for. This value you already know, 4 plus 1. So mod of z plus 2 will be less than or equals to 5. So maximum value will be 5 from here. And from here you will get the minimum value. Again the same. Here you have to figure out, you have to create mod z plus 2 with the help of z plus 1. So z plus 1 minus, sorry, z plus 1 minus minus 1. Can we do that? Z plus 1 minus minus 1. We can do that, right? Greater than or equals to. So this is mod of mod z plus 1 minus 1. Okay, mod z plus 1 is 4. So 4 minus 1, 3 ka mod is 3. So z plus 2 ka mod is greater than or equals to 3. So the minimum value is 3. As simple as possible. The most simplest application of this thing. Okay. All right. Clear? Chalo. Let's now talk about this. The second question. Find the maximum and minimum value of this if mod z minus 1 is equals to 2. Right? Okay. So now there is another technique also to do these type of questions. Let's apply that technique. You are looking, it is given that mod z minus 1 is equals to 2. So this is representing a circle with center 1, 0 and radius 2. 1, 0, right? And radius 2, 1, 0. So this is, hold on. One, 0, and so this is yes, 1, 0 is center and radius is 2. So now z lies on this circle. What about this? Mod of z minus 3 by 4 mod of, so this is actually z minus 3 plus 4 iota, correct? 3, 4 is the center of this circle. Okay, radius we do not know. 3, 4. 3, 4. So 3, 4, this is 1, 2, 3. 3 is here, 4 will be here. Okay. Now, you are looking for, understand what are you doing? This is the point 3, 4, correct? The maximum distance from 3, 4 on this circle is what you are looking for, right? Very easy. So minimum distance clearly is this. Maximum distance clearly is, sorry. Minimum distance will be, so first of all you have to draw a line which passes through center and 3, 4. Now to get the maximum value, that means 3, 4 say it has to be at maximum distance. This is your maximum point. This coordinate you have to calculate, and this is the point of minimum, right? So now understand that, yes. Now can you just calculate the distance between, so this is O, let's say, this is P and this is R. Maximum distance is nothing but OP plus R. OP plus R. What is OP? Square root of 2 ka square plus 4 4s are 16 plus radius is 5. So this is your 20 plus 5, root 20 plus 5. This is your maximum value. Okay. Now minimum value. For minimum value, obviously this is the point, this is the minimum distance. So OP minus radius. OP minus radius. So OP is root 20 minus radius. OP minus radius. So root 20 minus 5 is absolutely right. This is the minimum value. That is the maximum value. Right? So geometrically, can you see the question became very, very easy, right? Okay, so this is very popular question. You can find these type of question in JEE Main previous year questions as well. Go and check it out. Okay. All right. Clear. Now, if mod z, again the similar type of question. Let's do it. So they are saying that this holds true. What is this? Mod of z minus 3 minus 5 iota is equals to 2. Center is 3 comma minus 3 comma 5 minus 5. 1 2 3 1 2 3 4 5. Radius is what? Hold on. 2. Minus 3 comma minus 5. Radius is 2. So this is the circle. Right? Now your z lies on this circle and you're looking for greatest and least value of mod z. Right? Mod z you're looking for. Okay. So basically you're looking for, what is mod z? Distance of z from the origin. So this is your origin. Right? This is your center. Okay. So minimum distance will be this. Maximum distance will be this. Again, same thing. This is minus 3 comma minus 5 and this is 0 comma 0. This is your O, this is your P. Now maximum distance will be what? OP plus R. So OP will be square root of 5 and 3. So 25 plus 9. Root 34 plus what? Plus 2. And minimum distance will be root 34 minus 2 because OP minus R. Right? OP minus R. Now difference between greatest and least. So greatest value is root 34 plus 2 minus root 34 minus 2. Correct? Root 34 cancel. 4 is absolutely correct for this particular question. All right. Okay. Perfect. Now let us do one last question of complex number from triangle inequality only. So here we have this question, right? Let us talk about this question. Mod of z cube minus 3 is equals to 3 mod z. Then the maximum value of mod z is equal to what? Okay. So in here, mod z cube minus 3 can be written down as, so this is actually becoming what? Mod of z1 minus z2 greater than or equals to mod z1 minus mod z2. This triangle inequality I am trying to apply because negative sign is there. So mod z cube minus 3 greater than or equals to mod of mod z1. So mod z cube minus 3. Correct? So mod z cube minus 3 will be greater than or equals to z cube minus 3. Now this expression they are saying this is your 3z. 3z will be greater than or equals to z cube minus 3. Correct or not? Yes. So now you just have to solve it out. So z cube, sorry, this is mod z. Right? This is also mod z. Right. Mod z. So yes, clearly mod z cube. So this is actually becoming what? T cube minus 3t minus 3 is equals to 0. Now you just have to solve this cubic equation to get the answer. Now to solve the cubic equation, z square है क्या? Sorry, there is a mistake. There is a mistake in the question itself. So many mistakes in the slides. What is happening? Okay. This is actually z square. Now again do it. Again, triangle inequality, right? So mod of Z1 minus Z2 greater than or equals to mod Z1 minus mod Z. Correct? Mod Z1 minus Z2. So this is Z square minus 3 mod greater than or equals to mod of mod Z1. Mod Z1 is what? Mod Z square minus 3. That's it. Okay. So in here, this can be replaced by 3 mod Z greater than or equals to Z square minus 3. So Z square minus 3 Z minus 3 less than or equals to 0. Right? So we can easily calculate. So t cube minus 3t minus 3 less than or equals to 0. You can square. So you can just calculate the quadratic equation less than 0, right? So this is going to be 3 plus minus square root of b square 9 plus 4 3s are 12. 12 plus 9 is 21 by 2. Understand? T is always positive. So this is it. Okay. So this is saying that this is 3 minus root 21 by 2 and 3 plus root 21 by 2, and this is your wavy curve. But this is a negative quantity. Here it is 0. So obviously we cannot accept negative quantities because t is what? Mod z is always positive. So we are only looking for the positive values. So that's why only this range will be accepted. This is your mod z. Mod z will lie between 0 and 3 plus root 21 by 2. Now just tell me, maximum value of z is obviously 3 plus root 21 by 2. Option B is absolutely right. Okay. So with this session, we have successfully finished complex numbers. And I know that you are asking about circles, about conic sections, about integral calculus, vector 3 geometry. So many chapters are pending. So one by one, we will be tackling each and every chapter. Do not worry about that. And on this note, this is me, Namrata, signing off.